Hi everyone, my name is Rutuja and welcome back to DataToCrunch. In today's video, we will try to build one another end-to-end ETL pipeline using Azure. So for this, imagine that you are working at a company that still stores their data on premise, but your analytics team is in the cloud. So how will you get that data from on-premise to Azure? Then how will you clean it, model it, and depending on that, how will you build those dashboards so that your team can use it instantly? So for that, today we will learn how we can move the data from on-premise to Azure Data Lake Storage Services using Azure Data Factory, then how we can clean that data and transform that data using Azure Databricks. And afterwards, we will store that data into Azure Synapse Analytics so that any of the team, like data analysts or data scientists or BI developers, how they can access that data from Azure Synapse Analytics or pull that data from Synapse to Power BI so that they can build reports and the dashboards. So this is how our today's project looks like. So now let's jump to our data and let's try to understand our data first. Today we are going to work with this AdventureWorks sample databases which is provided by the Microsoft. So to have some overview about this AdventureWorks is a fictitious company that basically manufactures bicycles and their related products. Okay. So Microsoft has given us so many backup files which we can download. We have OLTP also, data warehouse also, lightweight also. So amongst this, we are going to focus on this AdventureWorks 2019 backup file. So just simply click on that and that file will get downloaded and we are going to store this backup file into our SQL server. So before that, we will see our database. So this database on which we are going to work, it contains so many data, so many departments information, like for example, human resource, then person, production, purchasing, sales, and so on. So for the today's project, we are going to focus on this human resources department, and it has so many tables, like 6 tables, which is like department, employee, department history, pay history, job candidate, and shift. So we'll see this step by step, but before this, let's try to understand our project workflow so that it will be easier for us to understand all these steps. So now let's jump to our project workflow. This is how our project workflow looks like. So the first thing which we are going to do is we are going to download and install SSMS, which is nothing but SQL Server Management Studio. And in that, we are going to restore our backup file which we have just downloaded. So this will be our on-premise SQL database. Okay. So now we need to move this move this on-premise database onto our Azure services, right? So in Azure, we are going to utilize Azure Data Lake Storage Service, then Azure Data Factory, Databricks, Synapse Analytics, Key Vault. And once we are done with that, we are going to connect our Power BI to this gold layer so that we can create reports and the dashboards. So the first thing is that we need to move this data. So for that, we are going to use this Azure Data Factory. So in this data factory, we will use copy activity, which will fetch the data from SSMS and then it will push the data to the ADLS, which is nothing but Azure Data Lake Storage. So in this ADLS, we are going to follow Medallion architecture. So this Medallion architecture is a data management framework which is used in modern data lakes and the data warehouses. So it has 3 layers: bronze layer, silver layer, and the gold layer. So each one of these layers has some purposes. So for the bronze layer, it stores raw and unprocessed data, which we have just moved from SQL database to the Azure services, right? So once we are done with storing our uncleaned data into bronze layer, the next duty will be to clean that data and transform that data, right? So for that, we are going to utilize Azure Databricks. So we'll pull this data from bronze layer into Databricks, then we will perform some cleaning activity, transformation activity. And once our data has been enriched, we are going to store that data into our silver layer. So now, once we have stored that data, then the next step would be of Azure Synapse Analytics, right? And then once our data becomes business ready, then that business ready data we are going to store into our gold layer. So basically, you can say that this is nothing but a serving layer. So from this gold layer, these different teams can access their respective data and then can perform their further analysis, whichever is required from their end, right? And along with that, we can also connect this gold layer to the Power BI so that we can create different kinds of dashboards and reports to represent it in front of the businesses or the stakeholders. So this is how our project workflow looks like. And while performing all these activities, we need to provide different accesses to ADLS. Then we need to create some app registrations, or we need to store some secrets or maybe passwords. So for that sake, this Azure Key Vault we are going to use. So we will not need to hard code anything like password or connection string, API keys, secrets, anything which we will not need to hard code. We'll just store that data into Azure Key Vault so that it will this Key Vault will manage this sensitive information, and it will help you to keep your all the passwords very safe when you are doing code or when you are creating ETL pipelines. So for that, we are going to use Azure Key Vault. So this is how our project workflow looks like. So first, now we will just see how we can download this SSMS and then how we can restore this file into SSMS. So this would be our first step. So now let's jump to that. First, we are going to download and install SQL Server. So for that, come to this link. You will get so many options for the SQL Server. So amongst this, we are going to use this Express, which is specialized edition. So just download on that. You will get that downloaded file. Just say yes to do you want to allow this app. So amongst this, we are going to work with basic installation type. Then accept it. Then wherever you want to store your files, just give that respective file and just click on install. So it will it will install your SQL Server. So basically why we need this SQL Server, right? So it gives us some database engine, right? Which is a core system that stores and processes our data. So for that, we need this SQL Server. So first we are going to install it. So once we are done with this installation, we are going to download this SSMS, which is SQL Server Management Studio. Just click on the first link and we need to download this. You will get this download option here. Click on that. So once it's downloaded, we need to set up it, right? So just click on this folder which we have downloaded. So basically it will give you some pop-up and you just need to click on next and then just finish your installation. Right now it's giving me error because I already have this SSMS downloaded and which is running on my PC right now. So for that sake it is giving me error, but in your case it will give you options. Just click on next and lastly just install it. So you will be done with this Microsoft Server Management Studio installation. So as we know that first we have downloaded that SQL Server, right? And then next we have downloaded this SSMS. So SQL Server, we know that we have downloaded it for the data to serve it as a database engine. Now we have this database engine, right? So we need to interact with this engine, right? So for example, we need to query our data, we need to manage our database, and we need to see like what's actually happening inside, right? So to interact with that, we have this SSMS tool. So this SSMS will act as nothing but a tool to interact with this engine. So this is how this SSMS will function. Okay. So once you are done with this, you just search for your SSMS option. It will give you this pop-up and that SSMS will get opened. So we have server type. We need to select it as database engine only. Then the server name. We have downloaded it as a SQL Express, right? So it has came as SQL Express. If you want to change it, just click on this arrow and you will get other options, and then just click on the option which you need to select. Authentication type, I'll keep it as Windows authentication only. Encryption mandatory is fine. Just click on this trust server certificate, and then we need to connect it with our databases. So this is our SQL Express and we are just connected with our databases, right? So now we will see how we can restore our backup file which we have just downloaded into this SQL Express. So now the next step is to restore your backup file into databases into your SSMS. So now the file which you have downloaded, it must be under the downloaded section. So you need to move that file from the downloads to this backup file. So this would be the path. In your case, it might be a little bit different, but most probably it will be under C drive, program files. Then under that you will have SQL Server folder. Then in that SQL Express, MS SQL, and in that you will have one backup folder there. So in that backup folder, you just need to copy paste your backup file. So our backup file is 2019.back, right? So I have just moved that file to this path, and now we will see how to restore it. So we have this databases section here. Just right click on that and you will get the option of restore database. So now just click on this device and browse it. Then click on add, and here you will get all the backup files which you have under your backup folder. So we have just moved our backup file here, right? So we will just select that file, click on OK, OK, and it will be ready, and just simply click on OK. So it will take few minutes. Okay, our restoration has been successful. So now some may ask, right, like why we have downloaded that backup file and we just restored it here. So like creating a new database and then adding different tables here, so it would be a lengthy process. So to avoid that, if we have given that option which is given by the Microsoft has given us ready-made backup files, right? So we are just trying to utilize those files so that to make our process a bit easier. Otherwise, if you want to like create databases and manually add tables, you can do that also. So right now I'm just preferring the path which is simpler, and we have given that files by the Microsoft. So I'll just restore that file. So now we have these different tables here: human resource, person, production, and so on. And as I have told you earlier, we are going to utilize human resources files or tables here. So if I'll just right click and I'll say top 1000 rows or 100 rows, it will give you the table or the results. In that you can see what are your files, like what are your tables, what are your column names under that, what are the typical types which we have under that tables. So this is our employee table, which contains national ID number, login ID, job title, birth date, gender, and so on. Then we have employment department history. It has business entity ID, department ID, shift, start, end date, modified date. Then we have this pay history. In that they have mentioned what is the rate, when that rate has been changed, what's the frequency of your pay. We have job candidate table also. It has job ID, then business entity ID, then it has a link for the resume, modified date, and the last table would be shift. It has given like what are the shift, day, evening, night, what's the start time for the same, what's the end time, and the modified date. So this is how our data looks like. So now our next step is to pull this data into our Azure services, right? So now let's jump to that procedure and let's see how we can push or pull this data using Azure Data Factory into ADLS, and we'll see and we'll try to explore other services also. Now let's try to learn more about management level and the hierarchy. So Azure provides you with the four levels of management. So the first one is management group, followed by the subscription, then the third one would be resource group, and the last one is the resources. So if we talk about the management group, so it basically helps you to manage the access, policy, or the compliances for the multiple subscriptions. So all the subscriptions in that particular management group, it automatically inherits the conditions which are applied to that respective management group. So subscription, like what is subscription exactly? So subscription, we can say that it logically associate the user accounts with the resources which they create. So each subscription has limits or the quotes on the amount of resources it can create or use. So organizations can use these subscriptions to manage the costs or the resources which are created by that particular user or the team or the project. So basically in the company, what they do that for any respective team or that particular user, they will allocate one subscription so that whatever user will create across that subscription, that will get billed for that subscription. So it will logically associate that user with the resources which they have created. So this is how this subscription level works. Then the next one is resource group. So if we talk about it, then the resource group, we can say that is a logical container where you can deploy and manage the Azure resources like virtual machine, web apps, databases, or the storage accounts. So we can say that it is nothing but a logical folder in which we are going to store all our resources. And resources are nothing but the instance of your services which you can create in that resource group. So in our case, we have these services, right? Which is like ADF or the Databricks. There are Synapse also, which we will use into any another project, or SQL database or ADLS, or like any virtual machine. So these all are nothing but the resources, which are nothing but the instances of the services which you can create. And we basically what do we store all these services into a particular folder. So that folder is nothing but a resource group. So in this resource group, I can say that I have stored this SQL or the ADLS. So that depends on you. So what we'll do, like we'll have subscription. If you have free account, then you will get that subscription for particular dollars for the free. Or like if you're using pay as you go, then you will create one new subscription. And in that new subscription, then you will create this resource group. And in that resource group, you will create all the resources or instances which we are going to use to create our ETL pipeline. So this is how this management level and hierarchy works. So now we will try to implement this management level and the hierarchy in our ETL pipeline, and we'll see how we can create the subscription, then resource group and the resources, and via that or through that we will create our pipeline. So now let's move ahead and see our practical part. This is our Microsoft Azure portal. So if you are new to this portal, you can opt for this try Azure for free. You will get 200 USD for 1 month, and you can utilize Azure services for $200. So this is the most easy and convenient option. And after that, you need to opt for pay as you go. So you need to pay for whatever services you are using. So just click on this try Azure for free. It will ask you certain details of yours. Enter those details and you will land up on this dashboard. So this dashboard, you will get to know. And like you on the left hand side, you will have this option of home, dashboard, then function, apps, app services, Microsoft Intro ID. You will get latest used Azure services here. Recent, whatever work you have done, you will get here. And if you are not able to find any particular service, it's the simplest option. You search for that and you will get that option very easily. So now, as we have learned about our hierarchy, right? So first step would be to create the subscription, right? Or first just check for the subscriptions option. So these are your subscriptions. So if you're using this service for the free, you will get this Azure subscription one, and you will get all the like subscription ID, what's the current cost, status, all the details here. In that case, you just don't need to create any subscription, right? And if you have opted for pay as you go, then you need to create one more new subscription. Just click on add, you enter all the details and just click on review and create. So you will create one new subscription for that. In my case, I don't need to create because I already have one. So I'll just opt for that subscription, and under that subscription, I'm going to create resource group now. So for that, just click, I'll just search it for resource groups. So this resource group, I can say that it's nothing but a folder in Azure that where we can organize and manage all our services for a specific project. So for this project, I'm going to create this specific resource, and I'm going to store all my Azure services in this resource group, which will act as a folder. So once you'll click on create, in the basics, you need to select the particular subscription under which you want to create this resource group. Then once you select that, you will get resource group name, and you just need to give name for that. So let's say, suppose in our case, I'll say resource group on-premise work. You can give any name, whatever you want. I'll just give RG on-prem work. And then the region, you need to select your nearest one region. In my case, I'll select East US. Then next, tags, we don't want to enter any. Next. In the last, it will ask you, or it will give you all the details which you have entered, and then just click on create. It will take some time to create it. Okay, so now our resource group is ready. So this is, you just need to refresh it because sometimes it happens like it will not be visible. Okay, so now I can see that my resource group has been ready. Now, in this resource group, we are going to create all of our services. So let's just try, and let's just start with creating first ADLS, which is nothing but Azure Data Lake Storage Services. Now we know that our data is on-prem, and we need to push this data from on-prem to Azure. So for that, we are going to create first service, which is ADLS, which is Azure Data Lake Storage Services, which is a storage account. So in that storage account, we are going to create 3 folders for bronze, silver, and gold. So this first service we are going to create. Then we are going to create second service, which is Azure Data Factory. So this service will help us to push this data from on-prem to ADLS bronze layer. So for that sake, we are going to create Azure Data Factory, and along with that, we are going to create Azure Key Vault. So that this would be our third service, which we are going to create under this resource group using this create option. So we need this Azure Key Vault to store our sensitive information, because to access this on-premise data, you need to set up some permissions. Without that, your access will get denied and you will not be able to push your data to Azure services. So for that sake, you need to create some user ID and passwords, and you need to set that permission explicitly so that it will help this Azure Data Factory to push this data to ADLS very smoothly. And to store that sensitive information, we are going to create this Azure Key Vault, which will save. The first service would be ADLS. So for that, Just type storage account, click on this, click on create. It will give you subscription and resource group, which we have just created. So if in case if you want to create one new resource group, you have option from here also to create that resource group. So just click on create new, type your name and click on OK. That new resource group will get created. As of now, I would like to move ahead with the resource group which I have just created. Then you need to give your storage account name. So you just need to you can give any name whichever you want. So in this case right now I'll give the name as, for example, ADLS on-prem work. Okay, this is available. So we'll proceed with this. Region, you just need to give your nearest region, whichever you have right now. In my case, it's right now East US. Primary service, you need to select for what service you are going to opt for this storage account. So in our case, we know that we are going to create 3 layers, right? Bronze, silver, and gold, and we are going to store our respective data there. So my purpose here will be Azure Blob Storage or ADLS Gen2. So I'll select that. Performance, I have 2 tiers for that. The one is standard one and the another one is premium one. So the standard tier, we can say that it's suitable for general purpose storage needs such as like storing data, or in our case it's like storing data, right, and which we are going to access frequently. So for that sake it's standard purpose tier. And the premium tier you can use, and it is basically designed for high performance workloads that demand low latency and high transaction rates, for example virtual machine or transactional database or big data systems. So for that sake you can opt for premium one. So if we'll try to compare the cost models for the both, this standard one is cost effective, we can say that, and it makes basically this tier suitable for like budget conscious scenario where like you have high performance and there are no critical requirements for the same. And for the premium, the cost would be generally high than this standard one, and it reflects the superior performance capabilities. So if you if you need to opt for premium, you can opt for that also. In our case right now we don't need to opt for premium. Standard would be fine because it's budget conscious, right? So right now I'll select the standard one. Then we have redundancies. So now let's try to explore all these 4 types of redundancies first. Now let's talk about the Azure Storage redundancy offerings. So Azure Storage offers like various redundancy options basically to ensure that your data remains available and durable, and even in the face of like hardware failures or power outages or any natural disasters, we need our data intact. So for that purpose Azure offers this redundancy offerings. So these redundancy strategies basically reflects your data across the different locations by providing the protection against your data loss and ensuring that business continuity gets maintained. So this is the main purpose of this redundancy offerings. So the key purposes of this storage redundancy would be like, first would be data protection, because redundancy safeguards your data from unexpected events such as, for example, hardware malfunctions or the data center outages. So it basically protects you with these such kind of outages, and it maintains the multiple copies across the various locations. So data protection is the main key feature for this, or key purpose for this redundancy offering. Then the next one would be Azure, this high availability. So by replicating this data, this redundancy ensures that your applications can access the data with minimal downtime even during the disruptions. So high availability is the second most important factor. Then the third one we can say is disaster recovery. So in the event of any regional disaster or certain redundancy options, it will basically allow you to get protected from these data failures by storing that data into a secondary region. So basically it facilitates the swift recovery and the continuity of your operations. So selecting this appropriate redundancy option, it depends on your organizational specific needs, balancing factors like cost or data availability requirements or the disaster recovery objectives. So there are so many things or the factors based on that, you need to select these one of like it's the redundancy offering which is best for your project. So the first option is locally redundant storage. So what happens in LRS? So LRS basically replicates your data 3 times within a single data center. So we have this primary region. So in our case, we have selected East US, right? So that is our primary region. In that primary region, we have data center. And in that data center, we have 3 copies of our data stored within the same data center. So that is how this LRS functions. So basically, this LRS safeguards your data or the activity against the hardware failures within the same data center. So it's good option, but the limitation for this storage would be like it does not protect against the data center wide disaster, like maybe for example fire or the flood. Then if that in that case, if that complete data center gets disrupts, then it is of no use. But it like rarely happens or will never occur. But there is a possibility of that occurrence. So for that purpose, LRS would be beneficial. And if your project has very minimal costing, then also you can opt for this LRS option. Then the second option is zone redundant storage. So what happens in this zone redundant storage is ZRS, it replicates your data across the 3 availability zones within a region. So we have our East US primary region, and in that region we have 3 different availability zones, and in that we have 3 different data center. So in LRS, our copy of our 3 copies were in like one data center, but in ZRS, our 3 copies would be into different data centers, but in a same primary region. So that is how this ZRS functions. So the next one would be geo-redundant storage, which is GRS. So in GRS, this GRS basically combines the LRS within the primary region and asynchronously replicates the data to a secondary region. So we can say that data is synchronously replicated 3 times within a single storage cluster in the primary region, and then it was asynchronously replicated to a secondary pair region. So this is our primary region. So in our case, it's East US. So in that data center, it has replicated your data 3 times synchronously, and like despite of this, it also replicates your data into a secondary region 3 times within the same data center. This is how this GRS function. So basically, we can say that it will protect or it will provide you disaster recovery capabilities in case of any regional outage. So like what would be the limitation for this GRS? Then we can say that failover to the secondary region, it requires manual intervention. So without that, your data will be intact in your primary region. So the fourth one is geo zone redundant storage, which is GZRS. So in this GZRS, basically this GZRS integrates with ZRS within the primary region and asynchronously replicates the data to a secondary region. So our data in our primary region East US, our data is synchronously replicated 3 times within 3 different data centers. These are synchronously replicated, and apart from that, it asynchronously replicates your data 3 times into your secondary region. So this is how this GZRS function. So we can say that it will offer you the enhanced disaster recovery and high availability. But the limitation would be for this would be like failure to a secondary region. Again, it will require manual intervention. Apart from that, your your data is already copied 3 times into 3 data centers into a primary region. So this is the I can say that this GZRS provides you the maximum protection to your data from all the disasters and recoveries, but it is not cost efficient. It requires a lot of cost. So it completely requires on your project requirement and the budget, which is like available and which is allowed to use. So this is how these are for redundancy storage services functions. For the cost purpose, we are going to opt for LRS, then click on next. Then on the next page, we will have this option of enable hierarchy. So it has some benefits. So once you will check this box of enable hierarchical namespace, it will automatically convert your storage account to ADLS Gen2. So once you will have this option, then you have some benefits of that. So one of that is you can create subfolders within folders and directories within that. So let's say suppose if you have one storage account, then you will not be able to create subfolders into that folder. So you just have to save all the data into that storage account. But if you have ADLS Gen2 account, then this feature will allow you to create subfolders within this folder. So let's say suppose this is my main folder, and then if I want to save my silver layer into that, then suppose if I would like to create one folder or one directory for that silver layer, then I can create that, and within that directory or that subfolder I can save my data. Similarly, I can create multiple subfolders or directories into that, so that it will make us easier to understand that data and assign particular permissions to that particular subfolders. So this is the one benefit which is called file system semantics. So this is one of the benefit. The second benefit, it would be like it will be compliant to ACLs, which is access control lists. So you can or you will be able to assign some fine-grained permissions to the specific files or the folders. So let's say suppose in our case we have fetched our data and stored our data into bronze layer, right? With the help of ADF, we have done that. Now we have created our Azure Databricks, and we need to fetch this bronze layer into our Azure Databricks to perform some cleaning and transformation, right? So for that, you need to set the permissions for that particular folder so that it will allow you to access, and it will allow the Azure Databricks to access this bronze layer files. So this is called fine-grained permissions, which is nothing but access control lists. So this is one another benefit which you will get with this enabling the hierarchy. So to convert our storage account to ADLS Gen2, I'm going to click on this option. Then with access tiers, I have three options, which is hot, cool, and cold. So each of these tiers has their own purpose. So hot tier, we can say that it is optimized for the data which is accessed frequently. So in our case, we are going to access our data frequently, right, which is stored in ADLS. So for that, this option would be beneficial. Then we have another tier, which is cool tier. So this layer is optimized, or this tier is optimized for infrequently accessed data. So in this infrequently also, that means that at least once in a 30 days. If you are going to access your data at least once in a 30 days, then this option will be better. Full tier will be better for that. Then we have third one, which is cold tier, which is also known as archived layer. So this layer is beneficial when you rarely want to access your data. And rarely, that means within 19 or 180 days, if you would like to access your data once in a while, then for that sake, cold layer will be beneficial. So if we talk about the costings for the same, then we can say that this hot layer, it has highest storage cost but lowest access cost. So suppose this is storage cost and this is access cost. So it has highest storage cost. On the other hand, it has lowest access cost. It is for hot tier. And if we talk about cool tier, it has lower storage cost and higher access cost. And when it comes to the cold tier, it has lowest storage cost. On the other hand, it has highest access cost or retrieval cost. So this is the difference between these access tiers. So clearly we know that in our case, hot tier would be beneficial to opt. So we are going to opt for the hot tier option, and then we'll move ahead. Then the access networking, we don't want to change anything. Data protection, keep it as the same. Encryption tags, no change. Then lastly, come to the review plus create and just click on create button. So it will create your storage account. So we can see that deployment is in progress. So it will take some time or like few seconds to complete your deployment. Our deployment is completed now. Then we'll click on go to resource. Here under data storage, we have these four options. Now let's try to see these four options very quickly. The first option is containers. So for these containers, think of it is like a folder in your storage account or in your cloud storage. So they store the files which are like CSV files, Parquet files, or maybe images or videos. So you can create folders within folders, you can create these and you can store your data into that. So we can say that it is used mainly for data lake storage services or for the analytics purpose. So this is the main purpose for the containers. Then we have second option, which is file shares. So for these file shares, we can say that this gives you shared storage which is accessible like a network drive using this SMB protocol. So often it is, we can say that this is mainly used for legacy apps or the teams which needs to share the files in Windows like environment. So for that, this file shares option would be beneficial. Then we have the third option, which is queues. So for queues, we can say that these queues let you send the messages between the applications or the services. Okay, so for this main purpose, we use these queues. So for example, let's say one system finishes a task and it sends a message, then another system reads it and it starts its job, next job, whatever it has. So for that purpose, queues will be beneficial. And it also helps with decoupling the systems in the distributed apps. So for that, queues option would be beneficial. Then we have fourth option, which is tables. So these tables provides you NoSQL queue value pairs. So this is great. We can say that for storing structured data like user profiles or app logs, but it is not used for the big data or the analytics purpose. So we can say that it can be queried very quickly for certain types of data. So for that purpose, tables is beneficial. So main purpose is for this is NoSQL key value storage pair. So we clearly know that in our case, containers would be beneficial. So we are going to opt for that. So now click on containers. Then we are going to create three containers. One is for bronze, then silver and gold. So we'll quickly create these ones. Okay. So this is ready. So as we know that, but I'll again tell, we have this on-premise dataset, on-premise database, and now we are going to pull this on-prem database with Azure Data Factory, and then we are going to store this data into our bronze folder or bronze layer, and that data is going to be completely raw and unprocessed. So this is our next step in which we are going to create ADF. But before that, to access this data from the ADF, we need to set certain permissions to the SQL and ADF too. Without that, this access won't be allowed and you won't be able to access whatever data we have, which is on-premise. So to access this data, to set this all the client secret and everything, before the creation of ADF, we are going to create Key Vault. So first let's try to create this Key Vault and then we will go for ADF creation. So now to create Key Vault, I'll just type Key Vault and select that option. So we have this option of create. Click on that. So if we talk about the purpose of creating this Key Vault, so the main purpose is to secure or to securely store our secrets, like in our case it would be like SQL credentials or storage account keys which we will create going forward. So for that, this Key Vault would be beneficial. And another benefit of this would be we can avoid the hard coding of sensitive information, like for example if we have passwords of anything, right? So instead of hard coding that passwords into our ETL pipeline, we can just store that passwords or the secret keys into this create key vault, and we can use this or access this key vault accordingly. So in short, we can say that this key vault is equal to password manager for our Azure. So we can say this is password manager of our Azure equal to Key Vault. So now we are going to create this Key Vault. Subscription is fine. Resource group, I would like to select whatever we have created, RG on-prem work. Then we need to give Key Vault name. Let's say, suppose in our case, I'll say on-prem work. That's fine. Region select, pricing tier. I would opt for standard because it will give you minimum cost. Click on next. Rest of the configurations, we are not going to change anything. Just click on next, and then lastly, just say review plus create. You can see that our deployment is in progress. So it is going to take some time to create this. Okay, so now our deployment is completed. Click on go to resource. This is our on-prem Key Vault. Under that, come to the objects, and in objects you can see secrets. Just click on that. Now we are going to create or generate this secret, right? But before that, we can see that it will not allow you to create because it is throwing us one error, which is this operation is not allowed for RBAC. So this is happening because we have not granted the right permissions for that. So if you'll see also to create it. Okay, so let's try to create it. Okay, so I have assigned one name, and then I have given one secret value, and then I'll just say create. So it will give you one error like creation has been failed. This is because we have not assigned proper permissions to that. So to generate these secrets, we need to assign one role for this, which we are going to assign through access control, which is IAM. Add role assignment. Then in this, we need to assign the role as Key Vault Administrator. So search for that respective role. Click on next. Then assign access to user group or service principal, which we are going to select because in this we are going to select our particular email address with which you have logged into this Azure. So select that particular email address and then click on next. So we can see that it is showing us this name, object ID and tab type as members, and then just click on review plus assign. So just remember that it is now showing us as your role has been added, but in reality what happens, so like to add this role and to assign this role to this particular key vault, it takes the time of like 5 to 10 minutes. So like if you'll go instantly and if you'll check or if you'll try to create secrets, it is going to throw you the same error again and again. So for that, it's just like take some time of 5 to 10 minutes, give that time, and then again try to refresh it. Then you will see that this error will be gone and you will be able to generate or import this secret. Okay, so
Because
now we
that
can
till
see
the
that we are able to create or we can create our secret. So for that, click on generate. Then you have to give one name for that. Let's say, suppose in my case, I'll give maybe on-prem vault. And then you have to enter one secret value which you will use while fetching this key vault or while using this key vault via Azure Data Factory. So for that, just give your any secret value for that. Then content type optional, we don't need any rest of the information, so let it be as it is, and then just click on create. So now we can see that our secret has been created and it shows the status as enabled. So now we are done with our Vault creation. Now the next thing is that we need to create our Azure Data Factory. So for that, I'll just go back to our resource group, which we have created. In that, I'll just click on create. Then we need to search for our data factory. We are going to create Azure Data Factory now. So now we can see that our subscription and resource group is correct. We are going to give one name for our Azure Data Factory. Let's say suppose I'll give Azure ADF on-prem work. Region, you can select nearest one. Version, let it be as it is, v2. Click on next. Rest of the information, Git configuration, networking, advanced tags, we don't need any kind of information, or we don't need to make any changes into that. So just click on next, next, next. And now we will create our Azure Data Factory. You can see that our deployment is in progress. Okay, so our Azure Data Factory is ready. Now click on Go to Resource. Just refresh the page. We can see now our one more resource group has been added to our resource group. So now before jumping onto our Azure Data Factory, we need to set some permissions to our Azure Data Factory. So till now we have seen that we have this on-prem database and we have this Azure Data Factory, and this is our ADLS Gen2. So now this Azure Data Factory needs to move this data from this SQL database to ADLS. So for that, ADF needs to access this SQL database. So for that, we have used Azure Key Vault, where we have stored our all secrets or all our credentials with which Azure Data Factory can access this on-prem database, and then it can move it to the ADLS Gen2. So to access this Key Vault, Azure Data Factory needs some permissions and or some roles. So we need to set one role, which is Key Vault Secret User. So this role will give permission to Azure Data Factory to access these secrets which we have stored in Key Vault, so that they can go to the on-prem database and then they can take that data and then they can move it to ADLS Gen2. So to set this role, we need to go to our Key Vault, come to Access Control, Add Role, Assignment. Here we have one role which is Key Vault Secret User. Okay, Key Vault Certificate User. Let me just confirm it. No, it's Key Vault Secret. It's Key Vault Secret User. Here it is. Click on Next. Here we are going to select Managed Identity. Select Members. From here we need to select Data Factory. Our Data Factory is ADF on-prem work. Select that and Review plus Assign. So we need this role assignment is very important. Otherwise, if we'll not give this role assignment, when we will go to our Azure Data Factory and when we will create our copy activity, in that we need or we have linked service option also, right? In that case, when we will test the connection or when we will run our pipeline, it will not run or it will fail, and it will give you one error as unauthorized access. So to avoid that error, we just need to set this permission to our Azure Data Factory. That's why this role assignment is very important. So now our role assignment is done. Then now we can go to our Azure Data Factory and now we can start creating our ETL pipeline. So this is our Azure Data Factory. We have 4 tabs. First one is Home, Author, Monitor, Manage, and Learning Center. In Learning Center, you have so many tutorials. If you want or if you would like to explore that, you can explore that. In the Manage section, we have linked service option, triggers, credentials, factory settings, integration runtimes. In the Monitor section, if you can check or you can monitor whatever triggers you have set, or if your pipeline is running, then you can check the status over here if it is in running state, success, failure. So everything will be shown in this platform or on this platform. In the Author tab, this one is important where we will create our pipeline. So here also we have options like pipeline, CDC, which is in preview status, datasets, data flow, and Power Query. So now we are going to create our copy activity and we will see how we can move our data from on-prem to ADLS. Before that, we'll just try to understand our data flow or how our pipeline will function. So this will be our ADF workflow. Let's try to understand it very quickly. The purpose of creating this pipeline is to move our data from this on-prem database or on-prem SQL to our ADLS. So for that, we are going to create our pipeline in Azure Data Factory. So in this situation, we have source and destination or sink, which is quite obvious. Source is on-prem SQL work from where we are going to extract our data and then transform it to our sink. So this will be our source, sink is our ADLS, and in that, to be specific, in ADLS we are going to store our raw and uncleaned data into bronze layer or bronze folder which we have created. So now we are done with source and sink. The next part is linked service. So we have linked service on both of the sides. One is for source and one is for sink. So this linked service, this will establish a connection between ADF and on-prem SQL Server. So to establish this connection from ADF to on-prem SQL Server, we need linked service. It will give you or it provides the Azure Data Factory with server name or database name or connections or credentials which we have stored into our Key Vault. So for all those, we need this linked service, one for the source side and another for the sink side. It is the same situation. We need this for the source or to establish the connection with SQL. And on the sink side, we need this to establish our connection with ADLS. Simple. So we have two linked services. Then we have IRs, which is integration runtime. Those also we have two, one for the source side, another for the sink side. But what happens is that in normal scenarios where we are like just doing copy activity or normal activity, Azure Data Factory gives us one auto-resolved integration runtime. So we just don't need to create one more, or we just don't need to create this integration runtime in those scenarios. But in this scenario, what is happening? We have one self-hosted integration runtime. It is just one another integration runtime which we need to create specifically in this scenario, because the role of this self-hosted IR here is to bridge the connection or to establish a connection between Azure, which is a cloud service or cloud platform, and your local environment, which is on-prem environment. So in our case, no, these two services or these two sources are not either on cloud or on-prem, right? One is on cloud and another one is on-prem. So for that, we need to enable some secure and encrypted data movement to shift our data or to move our data from on-prem SQL Server to ADF. So for that, this cloud IR or normal integration runtime, which our Azure Data Factory gives, it will not enable that access. So with this cloud IR, we won't be able to access this data directly. So for that, we need to enable or we need to secure this outbound access, which is self-hosted integration runtime. So this must be clear now. So to access this data from local machine to cloud, we need to set a separate access, or we need to give this self-hosted integration runtime, which is outbound access. We will see how we can create that also. So for that, we need this self-hosted IR on the source side. But on the destination side, now we are moving our data to from ADF, like we are moving data with ADF to ADLS, right? And those both are Azure services. So to move that data or to process that data from one cloud service or one Azure service to another Azure service, that normal integration runtime which Azure Data Factory is giving, that is enough. In this case, on the sync side, we need to create, or we don't need to use self-hosted integration runtime, which we need and it is must on the source side. So we are going to create one self-hosted IR, and this IR we don't need to create, it is there already. So we don't just need to explicitly need to work on that. So this is clear. Now we have dataset. Again, we have two data sets, one on the source side and another on the sync side. So let's try to understand them very quickly. So on the source side, this data set, it defines the structure and metadata for your SQL data which you are going to read. So basically this will specify the table or a query in SQL Server that ADF should extract. So for that, to set that, we need this dataset on the source side. Basically, this will just store structure and metadata of the data which you are going to fetch from the SQL Server. So for that, we need it on the source side, and on the sync side, we have this dataset. So on the sync side, it will define the destination structure where your data will be stored. So for that, we need this dataset on the sync side. So basically, it will specify the file format, then file path which you are going to set, and then what will be the structure of your data which you are going to save into ADLS. So to define that, we need this dataset on the sync side. So I think this is pretty much clear. We have source, then sync, then two linked services for both of the sides, then two dataset for both of the sides, and integration runtimes. One is self-hosted on the source side and the normal one on the sync side. So this will be our complete Azure workflow, which we are going to implement now. And in that also, I just forgot one thing. We are going to perform this copy activity, right? So in this copy activity, what will happen if we have seen on our on-prem data set, we have multiple tables, right? We have seen that we have I think almost 6 tables, right? So we can perform copy activity for the 6 of the tables, but to have that copy activity for this for 6 times for the 6 activities or for the 6 tables to move that data from one point to another point, that will be a sturdy task, right? And it will not be efficient, like you are having 6 copy activities into our Azure Data Factory and all of them are doing the same work. It's just that table name is different. So for that, what we can do, we can use this for each activity. So inside, we will use this for each activity, and inside that we will use this copy activity. So what will happen with for each activity? We are What will happen is, like, it will repeat the copy activity for each table or each data set you want to extract. So instead of just having 6 different activities, we will use that copy activity only once. And for that, we will use this loop, which is for each activity. So it will keep iterating for the times, or for how many, for the times like you have the tables. If in our case, if we have the tables for 6 times, then it will loop that copy activity for the 6 times. So in this, we will not be able to, like, or it will avoid multiple work, or it will avoid creating multiple copy activities for that. For that, we are going to use this for each activity. So now let's see and let's do practical and just create this pipeline. Okay, so now let's start with our practical work. Our first task is to create two linked services, one for source and another one for destination or sink. So for that, come to manage. Under the connection, we have this linked service option. Click on new. Our source is SQL Server, so we need to create a linked service for the same. So click on this SQL Server, continue. Give one name for your linked service, maybe SQL Source LS. And here now you can see connect via integration runtime. So as I have told you, ADF gives one auto-resolved IR. So this is that IR. But in our case, for the source side, if you remember, we need to create self-hosted integration runtime. So we are going to create that from here. So click on new. We can see that we have runtime setups as Azure self-hosted, link self-hosted. So click on self-hosted, continue. You need to give one name for your linked service. Let's say it's not linked service, it's integration runtime. Let's say suppose in our case, we'll give the name as on-prem IR. Okay, it should contain only letters or fine. On-prem IR. Click on create. So now we can see that we have two setups, one express and one is manual. So we are going to select this express setup. Click here to launch your express setup for this computer. So once you will click on that, you will get one downloaded app or setup. Click on that. It will ask you for the permission, say yes. Okay, so now we can see that that setup has been failed on my laptop because it states that it is already installed on this computer. So first I need to uninstall my IR which I have set up earlier. For that, I'll just go to control panel. Click on uninstall program. Then search for integration runtime. This is the one. Uninstall. Are you sure? Yes. So here I need to search for Microsoft Integration Runtime and then just select that and click on uninstall. And it is taking some time to uninstall it. Okay, so now again click on that setup which we have downloaded just now. Give the permissions. Now it will take some time to set up this IR on your respective laptop. So just wait for that. Okay, so now I can see that this Express setup has been successfully completed. It just took around 5 to 6 minutes to complete this activity. So I'll just close. Again, click on close. So now you can see that our IR is ready, but it's not currently available. So just try to refresh it. Once you will refresh it, you can see green tick mark here. That means that our IR is created successfully and it's ready. Okay, now we need to give server name and database name. So for that, come to your SSMS, right click, go to the properties, and here you will get your server name. Just copy this. And there is one more connection which you just need to cross verify, which is under the security and this server authentication, right? So make sure that it has selected SQL Server and Windows authentication mode. And if it is not, just switch it to SQL Server and click on OK, because it might give you unauthorized error while you are creating your link service and when you are trying to access this SQL Server data. So for that, you just need to make sure that server authentication has been set properly. Okay, so this is one more step or additional verification which you need to do. So we came here to take our server name, right? So I'll just select our server name again. Click on OK. I'll just give server name as which I have copied. Again, come back, copy your database name. Again, go back to Data Factory. Give your database name. Authentication type, SQL authentication, and username. Now we need to set this username. So for this, we have this syntax. Create login, name with password, your password. Again, create user under this login with this name. So to understand this concept, let's just try to understand it very briefly. So this is our on-prem work. This is our Azure Data Factory. And to access our data into Azure Data Factory, now we are configuring this self-hosted IR, right? So under this self-hosted IR, or to access this data from this ADF to on-prem, we need to set or we need to run two commands. One is SQL Server level command and another one is specific database level command. So this one is SQL server level command, and this one will be database level command. So with this, what will happen? This command, when we will run this command, right? So with this command, we are just creating server level login with the name on-prem work. So basically, it will say that, hey SQL Server, allow this user, which user? On-prem work user, to log in to your SQL Server with this password. So with this syntax, you have just entered or you have just logged into your SQL Server, but yet you are not able to access the databases which are under this SQL Server. So to access those specific databases, we are going to run this second command, create user some username for the login which we have created just now. So with this, what will happen that inside this SQL Server, you will be able to access particular database which you want to access. So for that, we have these two queries which we need to run. So run this query. Now what has happened? This ADF, this is SHIR, this is SQL. Now with this SHIR, we have set the permission to SQL Server level, then database level. So that it means that with this now we will be able to access whatever data which we have under this SQL database. Okay, enough of this. Now you just need to run this command and then come back to your ADF. Give that username which you have set over there. It was on-prem work. Give that name here. Now passwords. We are going to use our Key Vault passwords. So here also you need to create one linked service to access your Key Vault so that you can access that data more securely with this linked service, right? So I'll select new. I just need to give linked service name, maybe Azure Key Vault LS. Subscription, I'll just select my subscription. Key Vault name, our Key Vault name was on-prem work. Then just test the connection. It's successful, then create. Now we have created one more linked service to access our secrets or credentials from our Azure Key Vault. So now we can see that under the secret name, it's giving us the Vault Key Vault name which we have created. So that was on-prem Vault. Then encrypt, make sure that you are selecting optional because it might be mandatory also, but we need to opt for the optional. Test the connection. It's successful. Click on create. So now we can see that our linked service for source side is done. And under this, we have created one more linked service for our Key Vault. Let's just ignore this linked service because I was testing out something and I have created that for this. So just ignore this. We have these two linked services, or maybe I'll delete this. I don't need this. So okay, so now our link service for source, and inside that our another link service for to access the secrets is done. Now we need to create another link service which is for our destination. So our destination is ADLS Gen2. Click on continue. Name, maybe I'll give ADLS Sync LS. Here integration runtime auto resolution IR is fine. Subscription, select your subscription. Then storage name. I think our what was the storage name? Or ADLS on-prem work. Select that. Test the connection. Connection is successful. Create. Okay, so now our linked service creation part is successful. Click on author, and now we are going to create pipeline. So right click, new pipeline. Our pipeline name would be on-prem copy. I'll close this, and now under this I'm going to push or pull this copy data activity. So this is our copy activity. I'll just give the name of this activity as maybe copy only. Then come to the source. Just so here now, as we know that we are done with our linked service creation, now we need to create two data sets, right? One for the source, another one for the sink. So we will create this data set from here. So click on new. First data set would be for SQL Server. So select your source, continue. Select the name or give the name. Maybe SQL source DS. Then to establish a connection with dataset, we are going to select the linked service which we have created, which is SQL source LS. Then the table name, we can see that it's loading. So we can see that it states that no result found. But why is it happening, right? Because we have established a connection. So ideally it should give us the names or the table names which are here, right? But it is not giving because we have not set or we have not granted the permission to access those tables, right? So to grant that permission, we will write one query as grant select on schema, then double colon, and then under the schema, I don't need to access other tables, right? I just want to access human resources tables, right? So I'll just give the schema name as human resources to our database username on-prem work. So I'm just saying that, okay, under the databases, I want to grant the access for the schemas which are with the name human resources. So let's just execute this query. It has been executed successfully. Then come back to your ADF. Now let's try to refresh it again. I hope it will give all the names. Okay, now we can see that I can see the human resources table's name. Let's say suppose right now, as of now, I'll select the employee name or employee table or department table, anything. Import schema, I don't want to import it. Click on OK. So now source side dataset is done. Now come to the sync side. Again, we need another dataset for our ADLS Gen2. Click on continue. I would like to store my file, let's say suppose with the Parquet format. Click on continue. Give the name, maybe ADLS sync DS. I'll select the linked service which we have created. Now we need to give file path, right? So browse your file path. I want to save my data or I want to move my data under the bronze folder. Click on OK. So now under the bronze folder, you can create directory also, or you can save your file at that point with giving the name also. So from here, if you would like to give a name, you can. Otherwise, Azure Data Factory will give the name. Okay. Import schema, let's say no. Click on OK. So now we are done with setting up linked services, datasets, copy activity. Now let's just see if it is like moving the data or moving this particular department table into our ADLS or not. So I'll just select this and I'll click on debug. So let's just wait. It's in queue. In progress. Succeeded. Now let's see first. This is our ADLS account, containers, bronze. See, now we can see that that file has been copied, or that file respective that only one file or one table file which was of department, it has been moved from on-prem to our Azure account. But now I want to move all the data, right? So for that, we will see how we can use for each activity for the same. For that, I would like to create another pipeline for the same. Let's say suppose I'll create new pipeline. Right click, new pipeline. Maybe anything, any name you can give. For each move data. Okay, I'll just give this name. Before that, I'll just remove this file from my ADLS account. We are going to pull all the data again with for each activity. So I'll just delete this. Come back to Azure Data Factory. Let's try to understand our dynamic pipeline creation first. So let's say suppose this is my for each activity, which is going to iterate. Then under that, I have copy activity, which is going to copy the data from from source to destination. And I would like to create one more activity, which will be lookup activity. So let's see like how it will function. So the purpose of our dynamic pipeline creation is clear, right? To copy multiple data from source to destination without manually creating separate copy activities for each table. Because imagine that suppose you have 30 plus tables, then it would not be feasible to create to create separate pipeline or separate activity for each of the table, right? So to avoid such tedious and error-prone tasks, we need to create or we need to know about how to create these dynamic pipelines. Okay, so this lookup plus this for each activity with this copy activity all together will create or will help us to create dynamic pipeline creation. Okay, so let's understand the purpose of each of them first. So lookup activity, it will fetch the list of tables you are going to copy. Okay, so for that we are going to write one SQL query inside it. So this SQL query will fetch all the table names which you need to copy. So in our case, we have 6 table names. So this lookup activity will pull these 6 table names. Then once that task is done, once it is successful for fetching all these table names, it will tell us for each activity that okay, so now we have 6 table and now you need to perform your activity or you need to work on that. So let's say suppose our first table name was department. Then for each activity will take this first table name. Then it will trigger this copy activity. Then this copy activity will copy that data into our ADLS Gen2. Then again it will go back to lookup activity. It will take the second table name. For example, here it's employee. It will take the second name. Then it will again go back to for each activity. Then for each activity will trigger this copy activity. Copy activity will copy this data into ADLS Gen2. Then again this for each activity will go to lookup activity and will take the third table name. So in our case, we know that for each activity is going to loop on this one with for the 6 times. So this is how our pipeline is going to function. So I think it is enough to tell you about the activity because you must have gotten the idea about it, right? So the first one is we need copy activity. So I'm not going to create copy activity again and again. So I'll just copy whatever we created. So I'll just click on this, Control C, come back to another dynamic pipeline and do Control V. Okay. So now let's just drag two other activities. The first one was for each activity, and the next one is lookup. Okay. So let's rearrange everything. In copy activity, first thing is that we need to make sure that go to the resource, then open your dataset, and in here we need to check the table name because in the previous pipeline we have pulled the data of department table, right? But now we are going to use this dynamic functionality. So here we need to make sure that we are not having any specific table name over here. So if you have any, just remove it. Make sure that it is blank. Then come back to your pipeline. I'll just do Control X and I'll paste this into for each activity because it should be inside this for each loop, right? So Control X, click on Edit, paste it here. So here we have copy activity. Now I'll come back again to for each activity or on our main platform. Then this is our lookup activity. And now we'll try to work on this. So first name, I'll just keep it as it is, lookup. Then come to the settings. Here we know that the dataset is from source side. Source is our SQL, so which we are going to fetch our table names from the SQL server. So I'll use the existing dataset which we have created already. So this one is SQL Server DS. Then you need to make sure that you are unchecking this first row only block because we need to fetch all the data. Then, as I have told you, we are going to use SQL query to fetch that table names. So make sure that you are opting for query option. Then write a query as select name from system sys dot tables where schema id schema dot id is equal to schema underscore id of human resources, and then semicolon. Then timeout time 120 is fine. Rest of the things are okay. Now let's just check if it is working or not. So what we'll do, I'll just select the schema activity and I'll just click on validate, close. Maybe we'll debug it. Before that, I'll just make sure that I'm deactivating this for each activity and then copy activity. Now let's just, here is our lookup activity. Okay. Now let's just debug this and check if our query is working or not. Your lookup activity is in queue. Let's just wait. In progress. Failed. Maybe because of the query. Come back. Select name from tables where schema underscore id. Okay, now let's try to rerun it or debug it again. Okay, it succeeded now because that was query writing problem. Here it was expected that it should be underscore, so we have given full stop here. That's fine. Now let's just check if it is giving us all the table names or not. So for that, click on this arrow output, and now I'll just zoom it out. You can see that the count it is giving us as 6. Value it is giving us names as all shift, department, employee, table, department history, pay history, job candidate. So I think these are only the 6 table names which this lookup activity is pulling. So it means that our lookup activity is working fine now. Now let's look into our for each activity. So first we will activate our activities for each. I'll give the name as for each only. Then inside this copy activity, first I'll activate it. Okay, so now the next thing is that come to the source section, and now here we are going to use query again, and we are going to write our query using this edit option. So now we know that we have all the table names now. Now dynamically I need to assign those table names into my copy activity. So for that, let's see how we can write a query. So for that, just click on this box and you will get add dynamic content. Click on this. Now let's see how we can implement a query. So basically our query would be very simple, which will state select star from schema name dot table name, right? So we just want to write it as like select star from schema name with table name so that it will fetch all the table names here. So how we can write this query here? Let's just see. So for this, we'll need concat function, concat, and inside concat, we are going to write our query, okay, which is select star from, and then make sure you are giving space here, otherwise it is going to throw some error afterwards. Then dot. Now to give schema name, which is here schema name, what we are going to do, I'll write item dot schema name, comma, and then for this dot I'll give it into inverted commas, dot, again comma, and then now we need to give this table name, right? So for that again I'll have item dot, what's the table name, and then close the round bracket, and for this whole query it should be into curly braces. So this will be our query, which will indirectly mean select star from schema name dot table name. So here what we have done, we need this schema name and table name to be dynamic, right? So for the schema name to be dynamic, we are going to say, okay, from the items, just take that schema name and then dot, and again from the items, take that respective table name. So that if right now we have 6 table names, or then it will take one schema name, and from there it will take another that respective table name. So this is how it is going to function. So this is the way to write that dynamic expression, okay? So to understand it, I think it should be pretty much clear, but if we go into depth, this uh, curly braces, right? These one which we have gave, it will tell the Azure Data Factory that it's an expression that needs to be evaluated dynamic. So the purpose of these curly braces is that to tell the ADF that it's an expression which we are going to work, and it should be evaluated dynamic. Then we have this concat function. So this function will join the strings all together, right? So we have strings which is item schema name and then item table name. So to join those strings, we need this concat function. Then select star from, this one is going to be a static part of our SQL query, and same goes to this dot also. This is also going to be a static part. Then this schema name, it will refer to the schema name from the current item in that particular for each loop. And same, it goes to table name. It will refer to the table name from that current item in the for each loop. So this is how this query is going to function, okay? Click on OK. So now we have given this query, then come to sync, open this dataset, or then we'll create two parameters for schema name and table name here. So we have created these two parameters to pass the values dynamically from for each loop. Okay. So let's say suppose this is our ADLS account, in that we have this bronze folder, and into this bronze folder, let's say suppose I would like to have directory for each of the table. So department, employee, and so on, rest of the 6 tables. I would like to have directory for each of the tables. So for that, you need to pass the values dynamically to create these directories, right? So for that, we have created these two values, which are for current schema and table. So accordingly, it will create 6 directories into our ADLS bronze layer. So for that sake, we have created these parameters. Then come back to your copy activity. Now these created parameters will get reflected over here under the sink. So now we are going to pass dynamic content for the same. Okay, so click on this add dynamic content and then at the rate item dot, here we have given one parameter which is schema name, right? We are going to select that. Click on OK. So we are going to pass schema name dynamically, and now we also need to pass table name dynamically. So for that sake, again, click on if you click on this, you will get at the rate item instead of writing it manually. And then we have created another parameter which is table name. Then click on OK. So now our parameters which we passed dynamically are now OK. Now open your sync dataset again. Directory, we are going to add dynamic content for that. So that would be at the rate concat. Then we are going to concat schema name dot table name. That would be dataset schema name, then comma, into single inverted commas, slash, comma again, dataset, and then table name. So close your round bracket and then add this content into curly braces. So this would be our syntax to create the directories inside the for each activity. Click on OK. So now file name also we need to add dynamically. So for that, we are again going to add dynamic content for that. So that would be again at the rate concat. Then we are going to concat dataset, not schema name, it's dataset table name. And once you have done that, then I would like to add file format which is Parquet. And then everything needs to come under this curly braces. So this will be our expression to add file name dynamically. So it will take that respective name dot Parquet would be our file name. Department dot Parquet, employee dot Parquet, that would be our file name. So this is how we can add dynamic content for the file paths instead of just hard coding everything. So now let's try to understand this now. This is going to be our ADLS Gen2 account. In that we have this bronze folder, this one. So we are trying to understand our file path, okay? Inside this, we have one folder or directory which is for human resources. It will have name as human resources. Inside this, we are going to have 6 directories, okay? So these 6 directories will be for 6 tables. So this 6 directories. And inside these 6 directories, we are going to have their own Parquet file. So these directories will be created with this expression builder. This one will create this folder, and inside this folder it will create 6 subfolders or 6 subdirectories for each of the table. And then inside this we are going to have own Parquet file. Let's say suppose for department we will have department.Parquet file. So this file or this names will be dynamically created with this expression. So this is how this dynamic writing or dynamic file names or folder names will get named with these expressions. Okay, so now come back to your main activity for each. So now we have done working with lookup, then we have done changes, required changes into copy activity. Now we are left with this for each activity, right? So for that, come to the settings. We have items here. We need to add dynamic content for that. So just click on dynamic content. And now we need to tell for each activity that whatever the output which you will get from lookup, just take that and then do iterations on that, right? So for that, what we will write? Activity, then our activity name is lookup activity. Okay, so now this error is occurring because we have not connected these activities. So we have the here four tabs or four buttons: on skip, success, fail, and then on completion. So we need to instruct that once this lookup activity gets successful, then for each activity needs to perform, right? So we'll drag from on success and we will connect it to for each activity. Okay, so now we will try to check or add these items dynamic content. Now let's again try activity and then lookup activity. We need lookup activities output, and in that output we need 6 different values. So this will be our expression to execute. Click on OK. So now I think our work is pretty much done. So now let's try to validate our work. Validation successful. Let's just try to debug this. It's in queue. Okay, so it has been failed. Let's just see what's the output. For each activity, count 6. Then okay, so it took some time for me to analyze what the exact issue is. Now let's see what error we are getting. If we'll see the input of copy activity, it states that it has source, type, and SQL reader query. And in this query where we are concatenating schema name and table name, there we are getting the error. So I found the issue, I found the solution for the same. The issue was occurring here because in the lookup activity, we have given this query, right? So this is the query which we have given. So in that, we are saying like, okay, select the name from system table where schema ID is human resources. So in this case, what it is doing, it's just taking name and then it is taking table names for the same. Like let's say suppose if I have table name employee, then it is taking okay name employee, then again name department, and so on. So this is how it is taking the table names, but in the for each activity and inside that in copy activity, if we'll see here in the source, we are using this concatenation and over there we are preferring schema name and table name. So system is not able to get or Azure Factory is not able to get what is exactly schema name is and what is exactly table name is. It's just because we didn't define these two names. We have just defined name. That's why system is saying, okay, I know the variable which is named as name, but I don't know the variable which are schema name and table name. For that, we need to make sure that we are modifying our query, which is in the lookup activity. So I'm going to modify this query as this one, where we will clearly mention, okay, this name will be schema name, which is from system tables, and this name will be table name, which is from system schemas. And this is how we will implement join on that, and we will fetch that respective information from human resources table. So we are going to use this query now, and then it makes sense that inside that query, inside that copy activity, we are concatenating a schema name and table name. So this is how it will be able to identify, okay, now I have variable schema name and table name, and now then it will try to iterate on those respective names, and then they will get those names. Because of that, they will be able to copy that activity. So let's just copy and paste this query here. And after this, just we are going to just cross verify the variable names here. Okay, so we are going inside this copy activity. So we'll make sure that in this schema name S and M N is capital, because it can also cause issue. S and N needs to be capital here, and here also table name T and N is capital. Okay, now we are going to the sync, and inside the sync also we need to make sure that we are giving dynamic outputs, and those are S and N capital, and same goes to table name where T and N are capital. So I think so we are on a right track. Now, okay, we will cross verify one more thing. We'll go to this dataset, open. Here in the parameters, I have given S small and N capital, T small and N capital. So in the connection, where in the sync side connection, which is for the ADLS, which is for the dataset from ADLS side, we need to make sure that here we are giving those variables which we have assigned. So this schema name and table name is fine. And for the file, T is table name, T is fine. Okay. So I have cross verified the things. Now let's just first debug this activity first. Will take some time to execute it. Okay, it's in progress. Cute. Okay, one is filled. Rest of the things are working. Okay, so now one of our copy activity has been failed, and because of that, for each activity has been failed. Now let's just see what happened here exactly. So it seems like select star from human resources and employee table has some issues. Rest of the things we'll check. Department history successful. Department successful. Okay, so it seems like there is issue particularly with employee table. Now let's just check our bronze table. We have at least human resources table. And then we have five of the tables which has been imported, but one table is left and which is employee table. Now let's get back to our ADF for each activity, copy activity, then source site, preview data, employee. Okay, so now we can see that our rest of the things are working fine, but the column name organization node, it has some different kinds of inputs, right? We'll see. Let's just check this employee table. Then organization node. So this has some different kind of data type. I believe that's the issue, which is not able to be recognized here while we are shifting our or moving our data into Parquet file. So let's maybe open this data set. Schema. Let's just try to import the schema. For that, select your table here. We'll try to import the schema. Let's see if that's the exact issue or not. Okay, sorry. So our problem was with employee table, schema, import schema. Okay, so it has type as hierarchy ID, which is not compatible with the Parquet file format. So for this, maybe we can try to save our data into CSV file instead of Parquet file. Or if you want to save it into Parquet file only, then maybe first we'll see if that column is that much useful or not, or if it is needed to do any kind of analysis. So it seems like this column is of no use right now for us, and there can't be any kind of analysis based on this. So maybe we will try to skip this column name while importing the data. So for that, what we will do, we'll change our query, which we are using it here. Which is this query. So we need to change this query first. So let's quickly change this query. Okay, so now I have changed this query. So in this case, what I have done, I have given if condition. If equals to item name, item dot table name. If my table name is employee, then I'm just going to select these particular columns. In this, I didn't mention organization name, organization node column name. So apart from that, rest of the information we need. So for that, I have written this query, select these only column from the employee table. If in the loop, you get the table name as employee. And for rest of the tables, just do the exact same thing which we have done earlier. Just concatenate schema name and table name, and then dynamically create those respective folders and files. We'll click on OK. First, we will delete this information. or whatever tables we have imported earlier. Now it's clear. Let's see now if it is functioning properly or not. So before this, I'll just publish all my work just to save all my data or and work, because if you lose this data, then again you have to rework everything. Okay, published successfully. Now let's try to debug it. It is going to take some time. Okay. Yes, it has worked successfully, and our copy activity with for each and lookup has worked successfully. Now let's just check our bronze table. Okay, at least we have human resources. Then we have directories for each of that table, and inside that we have Parquet files. So it seems like our data movement or data copy data activity has been successfully done, which was from SQL to Azure Data Factory. So now our next part comes into scenario where our Databricks will come into picture. So now, till now, let's see what we have done. This was our SQL database. Then this was our ADF. So we have copied or pulled our data from SQL to ADF, and then that uncleaned and unprocessed data, we have stored it into Bronze. Now we are going to work with Databricks. Now this Databricks will fetch this unprocessed data, then we'll do data cleaning and transformation. And once that data will be enriched with these activities, then it will store this data into silver layer. So this is going to be our next step where we will do all these activities. Now let's see, and let's just create Azure Databricks first into our resource group. So this is our resource group, create. Check for Databricks. Click on this, create. You have to give a workspace name, maybe Azure Databricks ADB on-prem work. Region fine. Pricing tier, I'm going to opt for the trial one because it gives us 14 days free trial without charging anything. So that's the best optimum solution right now to work on these mini projects. Then we have manage resource group. So this is something like it's fine if you give it, or if it is also fine if you'll not give it, because when you create this Azure Databricks, there will be so many other resources which will get created in the backend. So this is basically the name to that backend resource group. So we have created one resource group here, right, where we are trying to store all our services which we are going to create, right? So if I'll give the name for this managed group name, let's say suppose if I'll give managed ADB work, then what it will do, if I'll give this name, then Databricks will create all those backend resources and it will store that resources into this folder, which is with managed ADB work. If we'll not give this, then also ADB is going to create backend resource groups and it will give any random name or system generated random name which will be given by Azure, and in that they will store the data. So it's just that giving the name or giving particular name to that folder. So if you want to give that name, it is also fine. If you would like to proceed ahead without giving that name, then Azure will take care of that. You just don't have to worry for that. So I usually prefer giving name. Let's say suppose managed ADB on-prem work. Next, rest of the things I'll keep it as same: networking, encryption, security, tags. Just review and create. Validation succeeded. Just click on create. You can see that deployment is in progress. It will take few seconds to create all the things. So now our Azure Databricks has been deployed successfully. So now we will launch the workspace. Log into your Databricks account. So this is how your Databricks account looks like. You have options for workspace, workflows, compute. Then you have SQL editor, view history, warehouses, everything. We are not going to cover each and everything in this project at least. We can have any another video which will be dedicated to this Azure Databricks. So as of now, first things first, we'll create the compute. Create compute. Unrestricted is fine. We'll go with the single node, single user with your name. Then runtime version. LTS is fine, 15.4. Then let's just opt for the minimum node type. Okay, we'll go for the standard DS3 v2. Inactivity after maybe 30 minutes is fine. Then click on create compute. So now it will take some time to create this compute. So before that, or till then, we will try to understand our next concept. So as we know that our data is into ADLS account in bronze folder, and now silver folder is going to come into scenario, and this is our Azure Databricks. Now this Azure Databricks needs to work on this data or needs to fetch this data from this bronze layer. Then after cleaning and transformation, then it just need to push that data into silver layer. But for this, to have that access to Azure Databricks to work and to interact with ADLS, we need to set the permissions explicitly. So for that, this Microsoft intra ID comes into scenario. So this intra ID will give or will set these permissions so that it will be able to access that information back and forth. So under this Microsoft Intra ID, we are going to have or we are going to do one app registration. So once we will do this app registration, it will give us some information like client ID, then secret ID, then rest of the information. We'll need 3 to 4 information. So with that information, we will use it into Azure Databricks. And then with this information, Databricks will be able to access this ADLS account. We need this information because Azure also needs to know that, okay, this is the valid person which is trying to access this account or trying to access this data. So to set that permission, we need this information which is important. So we'll see next how we can utilize this information into Azure Databricks to have the access to ADLS account. So now let's try to move on to that data. Okay, so now till cluster is becoming ready. So let's just go to our Azure account. Until then, we will do app registration. So for that, go to Microsoft Intra ID. Then we have app registrations. Click on new registration. Here you need to give your app name. Let's say, suppose in our case, maybe on-prem app. Rest of the information is fine. Just click on register. So in here, we need some information like client ID. We will note it down somewhere. So we need this client ID. Then we are going to require this directory or tenant ID. Then we are going to require one more value. So for that, come into certificates and secrets. Then click on new client secret. Description you can give if you want, maybe on-prem. Add. So now this value we are going to require. So I'll just copy this value, not the secret ID value, this value. We'll have this value. So I think we are done with our information collection. We will need these 3 values, and then we are going to fetch that, or we are going to work on our ADLS account. So let's just check our ADLS account. RG on-prem work and this account. Okay. So now let's see whether our cluster is ready or not. Okay, so let's just move ahead and jump to our next part. Okay, now our cluster is ready, but before that, we have created this app we have done this app registration, right, for on-prem app. So now we need to set the permission for this app which is registered into our ADLS account so that it can access that particular folder from this ADLS framework. So click on your respective ADLS account, go to IAM, then click on Add Role Assignment, search for the role Storage Blob Data Contributor, then click on Next, User Group, select that, select Member, search for your app name, which is on-prem app, select Review plus Assign. So now we have added that role. which we have created for that app which we have created just now. So it will take some time to access that role, but till then we will shift to our Databricks again. Come to the workspace. Here you have shared user access. I'll create one folder to save my work into that. It's always a good practice to have folder for your work. Inside this folder now I'll create one notebook in which we are going to work. So now first thing, connect your notebook to your respective cluster and give one good name for your notebook. Maybe I'll give on-prem silver work. You can give anything. So this is our notebook. You can run that respective cell from here. This is the language which you can set for the whole notebooks. You can change it to SQL, then your whole notebook cells will be into SQL. If you would like to change your language only for that respective cell group, then you can change it from here. Then to run everything in that folder or in that notebook, you can click on Run All. So this is how this notebook looks like. Now we will see how we can access this data. Okay, so for that, I'll search on the Google how to access ADLS from Databricks. Then you will get Microsoft links for that. Click on that. These steps are explained here also. If you would like to explore, you can explore it. Then this is the thing which we need. This is the information or language or coding we need. Just paste it here. First, we don't need this. Now we need to make some changes over here. So first thing, we'll start with the storage account, right? We have this information multiple times. So we need to give our respective storage account name here. So our storage account name is ADLS on-prem work. I'll just copy this and paste it here. Make sure that you are changing your storage account name wherever applicable. Okay, now we have done changes with storage account name. Now we have application ID, which is nothing but client ID. This one. So just copy this. Then just remove this and add original application ID here. Then we have directory ID, which one is this one, which is also known as tenant ID. Copy this, change it to this directory ID, and then value which we have this value which we generated by creating a secret. So we need to give this information over here. So make sure that you are giving double inverted commas and paste that information over here. Now we will try to run our cell and we'll see if it is working or not. It has been worked successfully. So now we'll use one more command for the Databricks utilities, which is dbutils.fs. So this is something with which or with this utilities you will get to know what are the files which are located within that particular location, right? So we have given our location name as ADLS on-prem work. Now suppose I would like to check what are the files which are present into this ADLS on-prem work. Then for that we have this dbutils command. So we will use dbutils.fs.ls and then ABFSS, our source is ADLS on-prem. In that we have bronze layer, so we need to access that from here. And then .dfs.core.windows.net /. Let's just run this cell. It has been ran successfully, and now it states that okay, into this you have one folder human resources. Okay, so now at least we know that we can or we are able to fetch our information successfully. Okay, so now it's always a good practice to first import all the commands which are required. Okay, so let's do that first. So for that, from PySpark.sql.functions import everything. For that, everything will give star, and then again from PySpark.sql.types and import all the types because we are going to require that, and then just run that cell. Okay, so it has been run successfully. Now the next thing is that let's just try to fetch all of our 6 tables one by one, and we'll see on each of them if you need to do any cleaning on transformation for the same. Okay, so now first we will start with department table. So for that we will assign one data frame name as df_dept, then spark dot read dot format. Okay, so let's just modify these things. So format is packet. I'll just add one back / and I'll take this to the downward. Option header is fine because we need header, otherwise if it will not give this header as true, then what it will do, it will give all the header names, and it will take or it will take all the header names as a first row, and you will not be able to get any title for that. So we need this header as true. Then infer schema, we need it as true because we would like Spark to read all of our schemas for those respective columns. And then load. We need to load our data, which is from ABFSS, bronze, from ADLS on-prem, bronze folder, into bronze folder. Now, I believe that we have one more folder, which is human resources. So this folder name we need to give here. And in human resources, we have one more folder, which is department. So this name again I need to add after this. And then let's just see if it is displaying it properly or not. Then df and display. Shift enter. Okay, it is fetching the data. If you'd like to see the schema for the same, then we can say that df_dept, then print schema. Then it will give you all the column names and their respective data types for that. So let's just see what data cleaning or transformation we can do here. Okay, so we need the department name, group name. Modified date is not necessary, I believe, and we don't have that much of information or like much information. So we can see that we don't have any null values too into this. So maybe we'll try to remove this modified date column because that's not necessary, at least for my analysis. So in here, you remember that this analysis or cleaning or transformation, you can do it on your own also. According to your analysis, you can decide like what interpretation you are going to do. So as of now, I'll just do it and I'll just try to show you few examples for that. but you have that flexibility to add more into that, or you can change it accordingly or as per your requirement. So here it's I'm doing it for the demo purpose so that we'll just see how we can clean the data in general or how we can work on that data. So let's say suppose if I would like to remove this modified date column, then what we can do, this is our data frame name which we would like to modify, then dot we need to use drop command, and in this drop command in inverted commas we need to give which column name we would like to drop, and then we'll just display this information. Now let's just run this cell. Okay, so now that column has been dropped. Okay, so I don't think so any other cleaning is required here. So let's say suppose for this data you would like to do some EDA, which is exploratory data analysis. For that, for example, I would like to check, or I would like to group by this group name, and I would like to check the count for what or for which group name, what's the count in this table. For that, what we can do, df dept dot, we will use group by command on this name, group name, column name, group name, and then count those values and then display it. So it states that for sales and marketing we have 2 values, research development 3, and so on. So here is plus button, click on that, visualizations. So if you come here, you can have different kinds of visualization, bar chart, pie chart, histogram. So according to your requirement and according to your ability and according to your analysis, you need to decide which visualization will fit for your analysis, and accordingly you need to set those visualizations for that. And if you would like to save, you can just click on save, and your respective chart will get saved here. So as of now I'll click on cancel. So this is how you can do EDA also. So I believe that this information is enough for this department table. Now let's try to write this data into our silver layer, and now we are going to write our data into delta format. So our data was earlier into Parquet format, and now we'll see how we can save that data into delta format. Okay, so now this is our data frame. We are going to use write command, then dot format, and it would be delta format. Then mode, I would like to give append mode instead of overwrite. Then we have option, dot option, and then we are going to set path for our data or information, and then that path will be, I'll give the same path, and instead of like bronze we will have silver layer. So I'll keep the same path. Just remember to change it from bronze to silver, and let's just run this cell. Now we'll check our silver folder. Okay, we have written everything, but we didn't say to save. So for that we have this save command. Again, we will try to rerun it. Refresh the folder. Now we can see we have human resources. In that we have department, and over here we can see our Delta file. Let's try to understand these two file formats very quickly. So the first one is Parquet file format. And by Parquet file format, I mean it supports columnar storage file format. Columnar storage file format means Parquet stores the data column by column and not by row. For example, let's say suppose I have one table and I have 5 columns into that, and now I require only one column for my further analysis. So for me, rest of the 4 columns are redundant and not necessary. So to avoid that fetching of all the information, all the values, all the entries, and all the columns, I can just fetch only one column which is required. Then I can do analysis based on that, and then I can provide the insights. So this columnar storage file format is supported by the Parquet. For that, it is beneficial, and with this we can mean that it will allow us to have faster queries. So instead of fetching all the values or all the columns, we can only fetch one column. That means that we are able to have faster queries. And because of that, it is efficient for the big data processing tools like Spark, Hive, and so on. So this Parquet file format has these benefits. Then the next file format is Delta file format. And this Delta file format means Parquet plus this transaction support. And this transaction support means Delta log. So altogether, Parquet plus Delta log, it forms our Delta file format. With this, we have some benefits of using this Delta log, which is which is a storage layer built on the top of Parquet and which is developed by the Databricks. So the first benefit is it supports ACID transactions. So this means that Delta guarantees us consistency. So let's say suppose if one write has been failed, then it will not corrupt all of your data. So we will be able to recover the remaining files. So just like database, it's safe and reliable. So this is one of the benefit which Delta gives. Then the next one is schema evolution. By schema evolution, we mean that, for example, I have read one data or file format and I have 5 columns into that. Now I have done analysis and I have done some transformation, and because of that, I have 6 columns now. So if we don't have schema evolution, it will not allow us to save these 6 columns into our ADLS account, because it will have difference between the column count. So while reading it, it was having 5 columns and now it has 6 columns. So it will not allow us to read that. Oh, sorry, write that. So with Delta format, this error will not be there or will not face this issue. So for that, we call it as schema evolution. Then the next one is time travel. And by time travel, it means that we can recover our older version. So let's say suppose I have done some analysis and I have saved these files. Now I have fetched this recent version and I did some analysis, and in that analysis I have deleted some records or I have deleted some columns, and then I have saved my data or I have written my data. This data will be new data. Okay, so afterwards I came to know that okay, whatever transformation I have done, that was wrong. So I was not supposed to delete respective column or particular column, or I was not expected to delete some kind of rows. So with this means that in this case, Delta will allow us to have time travel. That means that Delta will allow me to restore my previous version in which my data was intact. And with this, I'll be able to recover my older version, and then I can proceed with that older version, and then I can do some kind of transformations, new transformations which are expected from my end. So this means that time travel has been supported into Delta file format. So these are some benefits of Delta and Parquet file format. Now let's move on and let's work on another table. So first we are done with this department table. Now let's work on this employee table. So for that we will first read the data. Now for this I'll give maybe DPT EMP data frame equal to, I'll just copy paste the previous query in which I have read this department information. So instead of department, I'll have employee folder name. And then we need to display this data frame. Okay, this is our table which we have, in which we have business ID, ID number, login ID, level, title, and so on information. So let's say what data cleaning we can apply on this, or transformation we can apply on this. For example, I don't need these two columns because those are unnecessary for my analysis. Let's say suppose I would like to drop row GUID and modify date column. Then for that, what we will do, we will use our respective data frame, and then we will use drop command, and then I'll give these two column names which I want to drop, and then we will display our modified data frame. So now in this we can see that columns has been removed with our query. Now I can see that we have some null values into this. So for example, if I would like to delete the null values, then for that I'll use drop NA function. So let's try to work on that. Our data frame is df dot, we will use drop NA command. And I would like to apply it for complete table, then I'll just have parenthesis for this, and then I would like to display this data frame. Then let's just run this query. Okay, so now we can see that all of our rows with any null value into that row has been deleted. Okay, that's fine. That means that our query is working. Now let's say suppose I have this login ID column, and I would like to split this login ID column, and with that I will just take this username which is a login or login name. For example, in this I would like to just take TERRI0, in this Robert 0, then like whatever it is after forward slash, I would like to fetch that. So for that, what we will do, let's say suppose this is our data frame, then I would like to modify my respective data frame dot, we will use with column command, and in that with column command I'll keep this one column as it is, login ID, and we will create one more column for this. Okay, for that I'll give the name as maybe username. then comma, and for this we will split our existing column name column, which is login ID. So we are going to split our existing column login ID with forward. With this forward slash, we need to give it into inverted commas, and we need to give 4 forward slashes because we escape the backslash with 1 slash as a 4 slashes in Spark SQL. So for that, we need to give 4 slashes, which will get treated as a 1 slash. Okay. So if you'll try to remove this, then it is going to throw you one error. So we need to give 4 forward slashes, and then we are going to take first index value and then close your parenthesis. And then we are going to display our data frame. Now let's just try to check it. Okay, so now I'm expecting one more column. Yes, with username, where I'm getting whatever the expected user value which I was expecting from login ID column. So I think that it's enough analysis for this data frame. Now we are going to again write this data frame or write this file into our ADLS account with delta file format. So I will just copy paste the previous syntax which we have done. So our just data frame would be now df emp, and then we are going to store our data with employee folder instead of department folder, and we'll save our data. Now let's see if it is working or not. Okay, now let's cross verify. Okay, now we can see we have employee table now with delta log and Parquet file format. That means that our data has been written properly. Now let's try to fetch our next file from the bronze folder, which is employee department history. So again, I'll copy my Parquet file format with which we have read the data. Now our folder name is employee department history. So we'll just change this folder name, and then we are going to change our data frame name and make sure that we are reading the same data frame. Okay, this is our data. Now let's say suppose in this case also we are going to drop our modified date column. Okay, so the syntax is very simple, which we have seen earlier also. Now quickly do that analysis. Sorry, cleaning. It would be just dot drop and then our column name, which is modified date. And then we are going to display our data frame. Now let's say suppose with the end date we need to do something. So we have so many null values. That means that these data has not ended till now. For that, let's say suppose instead of like displaying null value, I would like to display is like maybe 999 12 31 as a date format. So instead of null, we will like to have, like we would like to have that respective data format over here, and the data and that date would be 999, the month would be 12, and then the date would be 31. So for that, what we can do, so now let's see. So for this, our data frame is this one, then dot, and then we are going to have with column, and our column name is end date. Yes, and then what we are going to do, redundant information I'll remove. So with column and then end date, comma, then I'll have when statement. In that, I'll check when the column name end date, what has happened? If the column end date is null, then assign the value as 9991231. Otherwise, whatever the column value it has, assign that value. So here I'm expecting null values to be treated as 9991231, and if it has that given respective end date, then I would like to have that existing end date only. So for that, this is the syntax. And then we'll try to see our data frame. So for this, we have used with column and when function, and in that we have implemented our requirement. So for that, let's just try to display this. Now here we can see that our null values has been changed, and in this value, our whatever our end date was, it has been kept as it is. So this is how we can implement this query. So now if any null value is present, then we will try to delete that row. So for that, data frame, then drop NA, and then we are going to display it. Okay, so I think it has no null values, but still it's fine, because earlier also those were 296 rows, and now also we have 296 rows. That means that this table has no null values. So now I think we are going to save our or write our data file into Delta format into our silver layer. So for that, again, I'll use the same query. Now our data frame would be different. And then I would like to give folder name as employee department history. Now let's run this. What's it saying? Okay. Now let's just check our silver layer, refresh it. I can see that I have now a new folder with employee department history and with its Parquet and Delta log inside that. Now I'll come to Databricks, and then let's try to read our Parquet file. I'm going to use the same query. Now our folder name would be employee pay history. I'll change the data frame name. Now let's try to display our new table. Okay, so what analysis we can do on this? For example, let's say suppose in here we have this rate change date and modified date with some format, right? Date format, then we have some minutes and so on. So now, as of now, let's say for example, for this, I just want only dates. So in here, I just want only 2009 114, 2014 630. So such kind of values I need. So for this, I would like to, or I would like to change, I would like to change the date format for these both columns. Okay. So for that, what can we do? Maybe employee pay history, and then we will use dot with column command, and in this with column I'm going to change, or I'm going to, okay, we will change the existing column only instead of creating one more column. The existing column name is rate change date, comma, and we would like to change the date format. For that, then we have function date format, then column rate change, then the format I would like to keep it as YYYYMMDD, and then again I would like to do, or I would like to change the next column, which is modified date. So I'll have just dot and I'll just copy paste the command, and instead of rate change date I'll enter this column name, which is modified date. Okay, and now okay, so we have given wrong data frame name. So it should be DF EMP pay history. So in this data frame, we are going to change, or we are going to modify two columns. One is rate change history and another one is modified date. And we are going to change their date format to YYYYMMDD. Now let's try to display this. Okay, now we can see that our date format has been changed successfully. 630. Okay, it means that it's working fine. Now we'll just check if it has any null values or not, or if it has, then we are going to delete or remove that respective rows. So let's quickly do that with drop NA function, and then we are going to display this data frame. Okay, this has been done. Now we are going to write this modified or cleaned data with or in delta format in our silver folder. So the syntax would be again same. We are going to change data frame name, df emp pay history, and then I would like to have one column also with emp pay history, and in that column I'm going to have those delta file format values or delta file format. So we are going to change this folder name. Now let's just check our silver layer. Okay, we can see that we have now folder with files inside it. Okay, so now let's try to work on next file, which is job candidate. So for this, we are going to read this Parquet file format with this syntax. Now our folder name is job candidate. So instead of employee pay history, just change it to job candidate, and data frame name I'll have as maybe job can. Now let's see our this new table, and let's see what kind of transformation or cleaning we can do into this. Okay, so it has columns as candidate ID, business ID, resume, and modified date. And this resume column is of no use as of now. So let's try to remove these two columns, resume and modified date. So for that, we have this data frame, then dot, we are going to use drop function, and inside drop we are going to give our two column names one by one. So first is resume, and then we have modified date. Now this syntax seems to be pretty much easy. Okay, so we have job candidate ID and business ID. Now I'll delete all these null values. So for that, again, we have seen this syntax so many times. Drop NA function. And display. Okay, that's fine now. So we will now write this file format with delta file format in our silver layer. Our data frame name is df job can. And now inside human resources, I'm again going to create job candidate folder, and in that I'm going to save all my work. So let's just change this folder name in our path. Now let's try to save our data. Let's check our silver layer, refresh it. Now we can see we have job candidate with its respective files inside it. Okay. Now we are left with one table, which is shift. So now let's try to read that data, and let's see if we can do any kind of cleaning into that. So for that, we will read our data, which is in Parquet file format from bronze layer. The folder name is shift. Accordingly, I'll change my data frame name. Now let's see. Okay. So I think we don't need any kind of change here. Maybe we can just change this file form, change this date formats. So for that, I think we have done this cleaning earlier also. We'll just check that syntax. Okay, this is that syntax. Now let's try to implement that into our data frame df underscore shift. So our column names are, first is start time, the next one is end time, and we have one more column, modified date. So we'll just add again with column into that. And now our column name is modified date. So now let's try to check, or let's try to implement this transformation. Okay, it seems working fine. I don't think we need any kind of further transformation for this. So let's just try to save this data in Delta format. Our data frame is df shift. And the folder name is shift. Now let's just check our silver layer. So now we can see that I have that last table saved here with Delta file format. So now we can see that we have cleaned and transformed all our 6 tables which we fetched from SQL database. So now in the next step, we are going to create Azure Synapse Analytics. So for that, we will go to our resource group. In here, we will try to create our Synapse Analytics. So search for Synapse Analytics. Create one. In here also, we have a manage resource group option. So we have seen in Databricks how this manage resource group functions. So similarly, it is going to function in Azure Synapse Analytics too. So for that also, maybe we'll try to give name to this managed resource group. Maybe RG managed Synapse Analytics on-prem work. Now it is asking to give workspace name for your Synapse Analytics. So maybe SA on-prem work. Region. Okay, it should contain only lower letters. I would like to select ADLS account from my subscription. So the account name would be ADLS on-prem work. Then the bronze file system name would be, we are going to fetch from silver layer. So silver. Next, it is going to create SQL Server admin login. So you can keep this name as it is, or you can change it also. Maybe I'll give on-prem admin, and then assign one password for the same. Remember this admin and password. Then next, so here whatever SQL Server admin login we have given, so these credentials which we are setting it for our dedicated SQL pool. So for that purpose, this admin and password is required. Click on next, next, review plus create. So it will need 5 USD to create this Synapse Analytics and to work on that. If you have serverless SQL account, then the costing would be 5 USD. That's fine. Validation is succeeded. Create. So it will take some time to create this Synapse Analytics. Till then, let's try to understand more about this Synapse Analytics, okay? So we can say that this Synapse Analytics, Azure Synapse Analytics, is a cloud-based data platform. So this data platform has been given by Microsoft that brings together the facilities or functionalities like data integration. So data integration includes maybe ETL or ELT. Then it also brings big data analytics, then data warehousing functionality. In addition to that, it also supports real-time analytics, and it also useful for SQL-based queries. So these are some benefits for this Azure SQL, this Azure Synapse Analytics. So we can say that this is altogether one unified workspace. Let's try to understand this Azure Synapse Analytics functionality. So let's say suppose you are at subway station or train station. Then you have one control room for your subway station. This one is control room. These are your tracks for your subway. Then this is your train. And these are people who are going to travel with this subway from this source or from this one platform to another platform. Another platform would be destination. So this control room, it would be treated as a Synapse Analytics. So this will be our Synapse Analytics, okay? Then this train, this is nothing but your data. These tracks, these are nothing but your data pipelines. And these people, that means that these are business users who wants that insights, okay? So in Azure Synapse Analytics, or this Synapse Analytics will have functionality where you will collect the data from different places. So you are going to collect that data from different places all together in one place or at one place. Then you are going to put that data on these tracks. That means in these data pipelines for the purpose of processing it or transforming it as per the requirement. So these data pipelines will do the functionality of data processing and transformations. And then this Synapse Analytics afterwards at the end is going to move this data from source to destination or from one subway station to another subway station for the purpose of creating dashboards and the reports at the end at the destination for these business users. So this is the simplest way I felt to explain about this Azure Synapse Analytics. So this is how this Synapse Analytics functionality works. So now let's move ahead. Our deployment has been successfully completed. Go to resource. This is our Synapse Analytics. Click on Open Synapse Studio. Select your account. This is how your Synapse Analytics looks like. It's kind of similar to Azure Data Factory. So you have home section here, then you have data section. In the data section, if you'll click on this, first you have workspace and linked option where you can see your ADLS Gen2. And this is our on-prem work ADLS where we have stored our data into 3 folders, silver, bronze, and gold. Then if you'll click on this plus sign, you will get SQL database, then Lake database. If we'll try to understand about these SQL or SQL and Lake database, then this Lake database, if you'll click on this, you will get two types of option. One is serverless and another one is dedicated. So this SQL database is nothing but, and it is also known as SQL pools for the for this Synapse. So it is, just a minute. Okay, so this SQL database is nothing but SQL pools for your Synapse. So this is nothing but a relational database, just like our SQL Server, but it is built for the cloud with Synapse SQL engine behind it. Okay, so this is built on the cloud with Synapse SQL engine behind this. So it has two types of Synapse or SQL pools. One is serverless and another one is dedicated. So this dedicated SQL pool, it has pre-allocated compute. So we can say that because of this pre-allocation, it is good for large data warehousing and their performances. So it is good for large data warehouses. On the other hand, this serverless pool, it runs with pay per query model. It has this pay per query model. So because of that, it has no infrastructure to manage. It has no infrastructure, and because of that, it runs with pay per query model. So with this, we can say that we can query the data directly from ADLS. So we got that functionality. We can directly make a query and we can access the data from ADLS. So because of this, we can say that it's great for exploration, and also it is cost efficient. So these are some benefits for this serverless SQL pool, and we also have seen this dedicated SQL database. Okay, so the next one we have is this lake database. So this, if we talk about this lake database, then we can say that it is a logical data model over your files which are stored in ADLS. So it works like a database, but it sits directly on the top of those files. Okay. So this is our ADLS account, and this lake database, it is a logical data model which is over the files of this ADLS. So this would be our lake database. Apart from that, we can say that this lake database, it is powered by Spark tables. That means that it supports Delta Lake format, and it is managed by Apache Spark and SQL, not SQL, by Synapse pipelines or notebooks. So altogether, it forms this lake database. So if we'll ask, like usually our data format is Parquet or Delta files, right? So when to use it, right? So we can say that when we are dealing with big or raw data, then in that case, we can refer this lake database when we are dealing with this raw and big data in the lake. And also when we want to create database structure over the files. So the next one is database structure over the files without moving the data actually. For that also we can use this lake database. Yes, so the last use case was when you want to integrate with data science or big data workflows. In that case also you can prefer this lake database. Okay, so if we compare these, sorry, so if we compare these two databases, okay, SQL and the another one was this lake database. So first feature, if we say about backend engine, then for the SQL database, the backend engine would be T-SQL or the SQL engine. And in Lake database, it would be Spark engine, which is nothing but Delta Lake. Then the next differentiating factor would be data location. The data location would be for the SQL database, it would be internal to Synapse, or it could be SQL pools. However, in the Lake database, it would be stored into your ADLS storage account. Okay. The next one would be format. So the format for SQL database would be relational tables. However, for the Lake database, it would be either Parquet or Delta Lake format. Then the next differentiating factor would be what is it best for? Then the SQL database is based for business intelligence or warehousing maybe, or for some fast SQL queries. So for that, we can refer this SQL database. And if we talk about Lake database, then it would be great for big data processings, where we are dealing with both unstructured and structured data. And the last differentiating factor would be computing models. So for SQL, it would be either dedicated or serverless, which we saw just now. And for the Lake database, it would be Spark pools. So this will be the difference between Lake and SQL database. So I hope this is pretty much clear. So now let's move ahead and explore another services or tabs. So under data, we have seen we have these pools and all. If we'll click on develop, then under develop, if we'll click on this plus sign, you will get SQL script, KQL script, Python script. So you can open that and you can write your respective code over here. Under the integrate option, we have this pipeline, link connection, copy data tool. So we can create our pipeline from here under the integrate option. Then we have monitor tab where you can monitor your pipelines if they are running, or if you have scheduled any triggers, then you can check the status over here if they are successful or failed. And if they are failed, then you can do the analysis, or you can check what query or what error you are getting exactly over here. Then we have integration runtime here also. Like Azure Data Factory, we can see we have auto-resolved integration runtime, which is given by the Azure to us. Then we have this manage option where we can manage our SQL pools or Apache Spark pools. We can see what triggers we have, access controls, Microsoft Purview also you can check it from here. So this is how this Synapse Analytics platform looks like. We are not going to that much details for this because we'll try to work on our projects and we'll see the required parts from this Azure Synapse Analytics. So now let's move ahead and see what we are going to perform in this Synapse Analytics. Okay, so now first things first, we know that in our Databricks scenario, we needed to set permissions, or we needed to give explicitly some permissions via creating or via registering that app using that Microsoft Intra ID, right? Over there, we have referred that. But in this case, we don't need this app creation and app registration because this ADLS and Synapse, these both are Azure services. So for this, we don't need to set, or we don't need to register anything, or we just don't need to do anything. It's just that we need to assign a role and we need to give that permissions to Synapse services to access this ADLS. So to give these permissions, what we need to do for this, come to your ADLS account, go to IAM, search the role storage blob data contributor, click on next. Now we need managed identity, select members. So inside manager identity, we are going to opt for Synapse workspace. Select your respective Synapse account. Click on select. Once it will get added under this members, say review plus assign. Okay, so it has been filled because it says that we have already added this role for our ADLS on-prem account. Let's just check access or role assignments. Okay, so we can see that our Synapse Analytics I have already assigned that managed identity to our Synapse Analytics on-prem work. So in your case, just cross-verify it if whether you have assigned that role to this Synapse Analytics or not. If not, then just add this role as I have told you right now. Okay. So now let's come back and we will try to work on our Synapse Analytics. And remember one thing, once you will assign that role here, right? Then it will take some 10 to 15 minutes to give that permission to your Synapse Analytics, and so that afterwards you will be able to access all your data which is into ADLS account. So you just need to wait for that and then you can start working for that. So if you'll check right away, then maybe you will not be able to access it. Then you just don't need to panic for that. Just wait for 10 to 15 minutes and then come back, and then you will see you will be able to have that access over here, and you will get all the layers here, and then accordingly you can check or you can work on that respective data. Now the first task would be to create your SQL database. Okay, so for that, come to your data tab. Under data you will get SQL database. Now we are opting for the serverless SQL database. Give some name for your database, maybe on-prem database, and then just create that SQL database. We can see that database over here, and this icon, right, with button for this database, it indicates that it is a serverless SQL database. Okay, so you can identify with this also that which database it is. Then next, now we are going to create our SQL script. So for that, come in Develop tab, click on plus, click on SQL script. Then first thing you need to make sure that, okay, first give this name a SQL script name, maybe script1, whatever. Then close it and make sure that you are connecting it to your database. So connect to built-in is fine, and then click on these three buttons, use database, and then select your on-prem database which you have just created, and then just close it so that it will be using your created dedicated SQL database. So now it's time to pick the data from your silver layer. So for that we are going to use on this open row set function. So for this, if we'll try to understand what's this function, then this open row set, this is a T-SQL function that lets you query your external data directly. Okay, so now in our case, our files are stored into ADLS, which is our external data, and this open row set will allow us, or it will let you to query this external data which is stored into ADLS account. So this is beneficial to use this open row set. So for this, let's think it as a bridge that helps you to run SQL queries on the files without loading them into this traditional database table. Okay, so this is very simple. Again, I'll say, think it as a bridge that will help you to run these SQL queries directly from your files without loading that data into your traditional database table. So this is the benefit of using this open row set function. Okay. So for this, now let's see and let's use this function. So the query is very simple. You just need to say select star from, then you need to use your open row set function. In this, you are going to give bulk. By bulk means you are going to assign your file path over here. So in our case, come to silver layer, human resources. Let's say suppose for the department or for employee, we will fetch one of this table. Let's say suppose employee table, come to the properties. Okay, so I just need to come inside this employee table. Then for that Parquet file, I need to go to the properties. You need to copy this URL. Come back to your Synapse Analytics, paste this URL. So now we will just remove this part because we are going to access till employee only, so that we will get all the files which are under employee folder. So after this, you need to make sure that you are changing this blob to DFS. Okay. So this will be the path which we are going to give using bulk option. And then you have format option where you need to describe which format you are using. So in our case, it was delta format. Okay. And then you just need to assign one alias for this. So as alias name would be anything. Anything as in anything. You can say query1 or ASD, whatever name you want to give. Give this format. And then we will try to run this query. Okay. So now we know that our data is into delta format, right? But using this open row set function, you will get the data into tabular format. Okay. So now let's just wait. So this is the data on which we have worked. Okay, and now we can see that our data which was stored into delta format, but using this open row set function, we are able to see this format into tabular format. Okay, into charts also you can see you have option to see it into a chart. This is the table. So now we have fetched over one of the table, right? Now what's next? Then we will create a view on the top of this query, which is this open row set query. And then we will store that into our gold layer, which from where we will use the Power BI to create the dashboards and reports. Okay. So now for that, to create a view, for first, what we will do, first we will create a schema. Okay. So to create a schema, what we can do, we'll just take one more SQL script. Maybe we'll give the name as create schema. To create a schema, we can say create schema, and then maybe my schema name is gold. Run it. It states that query has been successfully executed. Okay, I'll just add what I've done. I'll just add comment over here, schema creation maybe. Now the next step is view creation. Maybe for, let's say we will create a view for employee. For that, the syntax is very simple. We are going to create this view inside this schema, right? So for that, I'll write create view. Then I'll use my schema which I have created. Dot. I'll give my view name as employee. As. Then we will use this select query, same as here we have used. Okay, so I'll just copy this query and then paste it here. Select star from, and then this will be our query. Okay, so now let's try to run this query and let's see if we are able to create a view or not. Run this. Okay, so this has happened because when I created the new SQL script, right, I didn't connect it with my database which I have created, which is on-prem database. So just change that, and again I'll try to run this query. Okay, so for this we don't have schema gold for our on-prem database, so I'll just need to rerun it, and then we will create this view. Okay, so let's say suppose I would like to check if this view has been created or not. Then what I'll do, I'll just do select star from gold dot employee. We'll see if it is working or not. See, now you can see that this is the view which we have created on the top of our delta files or delta table. Okay, so similarly you can create view for other tables. Right now I have created for employee, right, and we know that we have 6 more tables, or say 5 more tables which are in silver layer, right? So I'll just quickly create that. I'll not show that into this video, but I'll create it. You also create it on your own. I'll just upload. I'll also upload this file into my GitHub account. So now let's quickly create it. Okay, so now I have created 6 views for our 6 Delta files into our Synapse Analytics. Now the next step is that we are going to create external tables into this Azure Synapse. Okay, so for that I'll just create one more SQL script, and I'll say name as external tables maybe. Then need to make sure that we are using our on-prem database. Okay, so now why do we need to create these external tables into our Synapse Analytics, right? What's the need of this external table creation? So when we are working in Azure Synapse, then creating these external tables is useful when your data is physically residing into your external storage. Okay, so in our case, our data would be residing into ADLS account, which is external storage for our Synapse Analytics, right? So to access this ADLS account, we have our data stored or physically residing into our ADLS account. So to access this data using T-SQL queries, it would happen by creating these external tables. So this is the reason. So because of this, we will get some benefits. The first benefit would be no data movement. So once you create these external tables, it will let you query the data which is into ADLS without the need of copying that data first into Synapse Analytics and then working on to that. So at the end, it will save your time and plus the storage cost. Okay. The next benefit would be leveraging existing data lakes. So if your organization already stores your data into data lake or in ADLS, then you don't need to duplicate it. You just need to expose that data using these external tables. So this one would be another benefit. Then the next benefit would be using T-SQL on this lake data. So you can run your standard SQL queries on any of your files, maybe Delta file, Parquet file, CSV file, which are stored into ADLS, which is super helpful for your data, which is super helpful for the data analysts or the business intelligence people who are using the tools, because they might be unaware about rest of the languages and how to query it. So they know about the SQL queries. So it would be beneficial for them also to leverage these facility and use this SQL queries, simple SQL queries, and then access the data and then work on that. Okay. Then the next one would be building semantic models. So after querying these external tables, you can join those external tables, or you can create the views, or you can feed those tables into your Power BI dashboard. So it will basically help you to build this semantic models also once you create these external tables. Then the next benefit would be data virtualization. So with this, I mean that it acts as a bridge between your data lake and Synapse Workspace without importing any kind of data into your Synapse SQL pools. So that would be your one benefit, which is data virtualization. And then the last one would be faster time to get your insights. So since we know that there is no need of ETL process to move that data from ADLS to Synapse, your complete ETL process, there will not be any need of that. So you can analyze your data much sooner and faster without creating or without doing this data pipeline creation. Okay. So these are some benefits which this external table will give you once you start using it. So for these benefits, we are going to opt for these external tables. Okay. So like in some cases, people might ask like why you are using this external table and not the managed table. Okay. So if we'll try to compare this external table versus managed table, then in our case, we are already storing our data into ADLS. So instead of like just importing that data into your Synapse, which any managed table would do, you can just take a reference of that place using these external tables. So this is one of the major benefit of or benefit for opting this external table. So by managed table means that in managed tables, you need to first load this data into your Synapse Analytics from ADLS. Then Synapse owns and manages that data, okay? And then it works on that. And in this situation would be good when you want to create warehouse style storage. So if you are going to opt for that warehouse style storage, then you can opt for this managed tables. But in our case, we already have our data into ADLS, okay? We just need to query it directly. We just don't need to perform any kind of transformation, or we don't need to save that into Synapse Analytics. For that purpose, our external table would be beneficial, and plus it will query it directly, so it will be very faster, okay? So in this case, and into on the top of that, we are also following Medallion architecture, right? So for that reasons, we are not opting for the managed tables, and we are going for the creation of external tables. So now let's see how we can create these external tables very quickly. Now to create an external table, the first step would be we need to set our password. Okay. So for that, we are going to use and create master key for the same. And at that time only we will set a password for this master key. So for this, if you'll search on the Google how to set or how to create master key in Synapse Analytics, it will give you this Microsoft page where we have syntaxes for the same. So we need this syntax, copy this, come to your Synapse Analytics. This one is not needed. I'll remove this brackets. And now we are going to set our password here. So the password would be like it's your choice what password you want to give. For example, if I'll give this password and then let's try to run this. Password validation failed, does not meet operating system policy because it's not complex. Okay. I'll just change the password. Okay, the query has been successfully executed. Then if we'll say like why do we need to create this master key and set the password? So basically what happens, this syntax, it will create your database credentials. So like database credential is not mapped to your server login or any database user. So this credential is used by the database to access that external location anytime. Okay. Maybe I'll add it as to access the external location. We need this we need to create this master key with the password. So this will create your database credential. Okay. Now, the next step, we are going to create database scoped credential using managed identity. So basically, why we need this managed identity, right? So this managed identity is a secure and recommended way to authenticate your Synapse or to allow your Synapse to interact very easily with other Azure services without storing any kind of credentials. So for that, we need managed identity. So we are going to use that managed identity to create this database scoped credential. Okay. So for that, the syntax would be create database scoped credential. Then we need to give our credential name. For example, maybe any name you can give. Then width, Then we need to assign identity, and our identity would be managed identity. Okay, so this would be our syntax. So now let's try to run this. So the query has been executed successfully. Now our third step would be to create external data source. So we need this external data source to establish a connection between your Synapse and ADLS account. Okay. So for that, we are going to create this external data source. In our case, we need to create two data source. One would be for silver and another would be for gold layer. Okay. So now let's try to create that. So for that, syntax would be create external data source. Then you need to give source name. In our case, maybe silver layer source with parenthesis, and in this you need to give first location. So the location would be, this one would be for the silver layer, right? So okay, so first I'll take any location from here. Come back to your Synapse Analytics. Then we are going to remove rest of the information. Then this would be our location. Then we need to assign credentials. Okay, I need to remove this backslash also. Then we are going to use our credentials. So our credential would be this one, which we have just created. So assign this credential here. So this one would be for silver layer. Let's try to execute it. What it says. Okay, we have forgotten comma here. Run it again. It has been executed successfully. And now similarly, we are going to create one more data source for our gold layer. So do mandatory changes whichever are required. Credentials, we are going to use the same credential. Then run this again. It states that our query has been successfully executed. Now the next step is to create your external file format, and this step is necessary to define so that Synapse will get to know that which kind of data or external data they need to read. Okay, so for that our syntax would be create external file format. Now there is one more thing, is that this external table file format doesn't support delta format. Okay, it always supports standard formats like delimited text, parquet. So now let's see, if I'll come onto this, if I'll search for this right on Google, you will get this link, how to create external file format using T-SQL. Okay, so if we'll come down, we have data compression method here, right? So they have given data compression techniques for like what will be for delimited text, RC, ORC, Parquet, then JSON. But for the delta table, there is no format supported. So in our case now, we are going to use or we are going to save our external table into Parquet format. Okay. So for that, where is my Synapse? Okay. Then the next one would be I would like to give format name, right? So let's say it was Parquet underscore format. This would be my file format name. Then with format type, declare your file format type, which is Parquet, comma. Then you need to mention data compression, and you will get this code for data compression here. Okay. I'll just copy this data compression. So if you are suppose saving this data into another format, let's just check that data compression, whichever is required. So right now I need this snappy codec. I'll just paste this here into inverted commas. Now let's try to run this and see if we can create external file format or not. Okay, now our query has been executed successfully. Then the next step would be to create these external tables. Okay. So the code for this would be create external table. Then we are going to use our schema which we have created, and that one was gold schema. Into that, let's say suppose we will first try to create a table, external table for our employee file. So this would be my name. Then you need to use with, assign your location. My location maybe would be external employee, comma, then what would be your data source. So my data source would be this one, comma, then file format would be this one. Then next, create table CTAS, as in create table as, and then I'll write the query select star from gold dot employee. I think this is the one which we have created, right? Let's just check first. Okay, this one, employee. Now let's try to execute this. Okay, query has been executed successfully. Now let's try to check if our external table is working fine or not. For that, what I'll do, select star from schema name is gold dot our external table name is ext employee. Run this. We can fetch this data properly. Okay, so that means that at least our work queries are working fine. Now let's come back to our gold layer. And if we'll see here, we can see our external employee table has been created, file has been created, folder has been created, and in that we have this Parquet file. So similarly, we need to create external tables for our rest of the files. So I'll just quickly create it. So the syntax would be completely same. Is instead of like here we will external employee, we will create external table for rest of the files, which are like employee. I think we have 6 tables, right? So we are going to create external tables for all these remaining folders or tables, and we are going to save that as gold.ext, then that respective table name. Okay. So now let's quickly create that first. Okay, so I have created remaining 5 external tables. In total, 6 external tables for our 6 files. So ideally, I should have 6 files in our gold layer. We can see that. We'll try to open it. We can see we have one Parquet file into this. So similarly, into Synapse Analytics, if I'll go to our data section, then in data section, we can see that under SQL database, we have these external tables which we have created. Then you can see your external resources which you have created over here. So we created 2 resources, one for gold, another for silver, right? So you will be able to see that over here. Then the file format which we have created, Parquet one, that is also visible here. Then the views, we created our 6 views here. So those are also visible here. Then schemas, it has been created by the system. This one is created by us, gold schema. So this is how we can see whatever work we have done, it's visible here. In this also we can see whatever columns are there with their respective data types. So these external tables are created successfully. We can say that in Synapse Analytics, and also we have all those external tables into Parquet file format in our gold layer. Okay. So now the next step and the final step in our project is to connect this Synapse Analytics to our Power BI. Okay. So for that, open your Power BI. If you don't have this Power BI installed, it's very simple. Go on to the Google search or type download Power BI, then you will get that link. Just download it and that desktop will be visible over here. So blank report. Now, so in Power BI, in home section, click on get data, more services. In this, we are going to get the data from Azure Synapse Analytics SQL. Click on connect. Server name, in our case, if you'll open your respective Synapse Analytics, on the right hand side, we have this serverless SQL endpoint option. We need this connection as an endpoint. So we'll copy this, come back to your Power BI, click on OK. So now in my case, it has directly connected, okay, because I have already connected Power BI to this database. But if you are connecting this for the first time, it is going to ask you to give credentials for the same, okay. So on the left hand side for the credentials, you will get this pop-up, and here you will have actually three options. Click on the second option, which will be, I think, database. And in that database, it will ask you to enter credentials, password, and username. So if you remember, in our case, while we were creating Synapse Analytics, right? At that time, we created one SQL Server admin and then SQL password, right? So that admin and password you need to give over here, okay? So you just need enter this admin and password in that pop-up which you will get here, and then click on connect. So once you will click on connect, you will get this database. So in this database, if you remember, we have created 6 views for each of the table, and then we created external tables too for each of the table, right? So these were like external department, history, employee payment history, job candidate, shifts. So we are going to select these external tables, and then we will click on load. It will take some time to load the data. So now once this data will get loaded, we will work on 2 to 3 charts. I'm not going to focus that much on Power BI to create exactly and proper dashboard and report. So I'll just show you how we can create charts from here, and then you can work on that, and respectively you can create your reports as required. So this is our dashboard of Power BI. If you'll see here, you will get table view. Here in the third option, you will get model view. So, and here you will have DAX query option where you can run your DAX queries. So in the report view, let's say suppose maybe we will work on or do this column chart. What is it? Stacked bar chart. And maybe from the department, let's say suppose group name, and on the x-axis we will have count of the group name. And then you can come to your format your visuals, data labels, you can turn it off on. And then if you would like to change the names of the same, x-axis, y-axis, general, here title, you can change the title, maybe department count. Then whatever are the requirements, if you would like to turn on the subtitles and everything, you can give it. Now let's say suppose we need to see employee hiring trend over the time. Maybe we'll use line chart, and for this we have into employee table we have this hiring date option. Remove this, we just need year, and let's just check business entity IDs. Okay, now I'll just turn on the data labels. So this would be the hiring trend over the years. So this may be one another graph. Now let's say suppose I would like to check the column count, sorry, employee count by the job title. Okay. For this, maybe if I had taken this stacked column chart, and maybe we have this job title. Okay, so we'll take this on x-axis, and then these business entity IDs, we will take it on y-axis. So this would be the employee count as per the job, as per this job title. So these are some few examples which I have shown you. There are so many analysis or insights you could get from these tables. So if you are performing or if you are working on this chart or report, let's just try to just execute other types of charts and try to explore how it functions or how each chart would function, or depending on that what type of insight you could give to the business that will be important for the business or the stakeholders, and based on that they will be able to take some kind of decisions for their respective business. Okay, so this is how we can connect Synapse to the Power BI, and this was our last step. I think this is it. So this was the project which I have tried to cover in this tutorial, in which we have seen how we can move our data from on-premise to Azure services. So for that, we have seen how to install SSMS, then how to restore our database into this SSMS, then how we can move our data to Azure services into our bronze layer using Azure Data Factory. So here we have created ADLS account, and in that we have tried to follow our Medallion architecture. For that we have created bronze, silver and gold layer. So with Azure Data Factory we have moved our raw and unclean data to bronze layer. Then we have implemented Azure Databricks. Over there we have cleaned our data, then did some kind of transformations, and then that enriched data we have saved it into our silver layer. Afterwards, we have implemented Azure Synapse Analytics, in which we have seen how to create the views, then how to create the external tables. For that, we have used the data which we stored into silver layer, and then after creating these external tables, we have saved these external tables into gold layer. From gold layer, any other department like maybe data analysts or business intelligence team, they can access the respective information or respective data which is required for their analysis. And then afterwards we have seen how we can connect this gold layer to Power BI, and then how we can access these external table into Power BI. And after connection we have seen how to create the dashboards and reports into our Power BI. So this was the project which I have tried to cover. I have tried my best to show you or to implement or to tell you the theory which is around this project or which was required for this project. And I know that I didn't cover another topics or advanced topics right now, but for sure I'll try to cover those topics into my next upcoming sessions, where I'll try to implement another projects. But as of now, if you know all those advanced technologies or all those advanced skills like maybe Unity catalog or any other things, then I'll urge you to go for that, to implement that, to have hands-ons on that, so that it will boost and it will enhance your knowledge. So I'll also try my best to cover those topics in my next upcoming sessions. So thank you so much. If you have liked this project, please like and subscribe. If you have any recommendation or any kind of feedback, please write that into my comment section. I'll try to help you out as soon as possible. And thank you so much. Till then, keep crunching the data.